technological innovations towards health, food, and nutrition security. Once again, I am Vanessa, and I will be your master of ceremony for our scientific session this afternoon. But before we proceed, we would like to remind all our participants to please sign the registration form at our booth near the entrance, and to please accomplish our evaluation form for days 1 and 2 using our QR codes. You may scan the codes for our evaluation forms at the back of the program brochure. You may also find it here on our screen. All right. We shall now have our rapid fire presentations. Are you all excited? Yes. Let's give our finalists a round of applause for making it to this rapid fire presentations. Our finalists have been determined yesterday after prejudging the portion of the poster presentations. From 74 posters, only 8 entries have made it to the next cut, and here they are. Today, our finalists will be put to the test as they will have to present their studies within 3 minutes. This will be followed by a 2-minute question and answer portion led by an esteemed panel of experts. Let me introduce our judges to you, everyone. Our first judge and lead judge is Dr. Leah Tolosa Croucher, a program officer from the Office of Special Initiatives at the National Center for Advancing Translational Science, or NCAT.
Hello, good afternoon, everyone, and congratulations to our finalists. I will be both the lead judge and the moderator. After our introductions, I will tell you what the guidelines are. Okay.
Thank you so much, ma'am. Our second judge is Dr. Carlito Lebril, a professor at the University of California in Davis. Please stand up so that everyone can see you. Maybe a little wave. Yeah, there you go. Our third judge is Dr. Casiano Vera Cruz, independent advisor at the Plant Pathology and Host Plant Resistance Unit under the Rice Breeding Innovation Division at Erie. Yeah, there she is. A round of applause for our esteemed panel of experts. Before we begin, please be reminded that we will be cutting off the presenter's mic after 3 minutes. So I will be saying time is up. After which, we will immediately proceed to the Q&A portion. Judges, please make sure your questions are succinct with respect to our time limit, because we only have 2 minutes. All right, are we all ready? Let us begin. We have with us our presenters. The first one, our finalist number 1, will be in the hot seat. Miss Paula Camille D. Ingalia. Are you ready, Miss Ingalia?
Yes.
All right, your timer starts. Your 3 minutes starts now.
Good afternoon, everyone. On behalf of my co-authors, I'm Paula Ingalia, and I will be presenting our study on microbial elicitation by co-culture of shipworm microbial isolates with shipworm opportunis Pseudomonas aeruginosa. Will you please flash the slides? Oh.
Okay, we will be pausing the time because of some technical glitches.
Slides, please.
All right, the slides are ready. And again, we shall begin. Your timer starts now.
I am Paula Ingalia, and I'll be presenting our study on microbial elicitation by co-culture of shipworm microbial isolates with shipworm opportunis Pseudomonas aeruginosa. Next slide, please. So antimicrobial resistance, as we all know, has been designated by the World Health Organization as one of the top 10 global public health threats due to the health and economic burden it entails. Next slide, please. Therefore, finding alternative sources and innovative methods to discover novel antibiotics is a global challenge. Next slide, please. So marine microorganisms are good sources of bioactive metabolites because of the distinctive environment conditions in the sea wherein nutrition is limited and the salinity is high. And shipworm or tamilok are bivalve mollusks, as we call them in the Philippines, and they harbor this diverse microbial symbionts and they are capable of producing potential antimicrobial compounds. Next slide, please. So a preliminary antimicrobial screening of shipworm symbionts revealed that antimicrobial potential of these isolates. Next slide, please. And our genome analysis of the isolates E2 and E9, focusing on biosynthetic gene clusters, showed that they can produce antimicrobial compounds such as tartralon and Turner Bactin. Next slide, please. And however, when we rely on microbial extracts as sources of antimicrobial activity, we observed a phenomenon wherein the antimicrobial activity of these isolates wane over time. Next slide, please. And in our experiment, repeated cultures of isolate E2, E7, and E9 led to reduced bioactivity over time. And we hypothesized that this decline is due to the monoculture environment where the microbes are no longer exposed to the natural cues or chemical cues present in its natural environment. Next slide, please. And to address this issue, we develop an approach based on the hypothesis that microbial interaction is the natural Tamilok environment stimulate antimicrobial activity in producer strains. Next slide, please. We use extracts from Pseudomonas aeruginosa, shipworm opportunist, and we co-cultured it with our isolates E2 and E9, and it shows that there is an increase in bioactivity upon co-culture compared to the monoculture counterpart. Next slide, please. Although Pseudomonas itself exhibited some background activity, the co-culture treated isolates showed a notable enhancement, as I've said, and this demonstrates that compounds from an elicitor microorganism can stimulate increased activity in microbial isolates. So our findings now suggest that we can further capitalize on this technique by identifying these compounds using the omics tools, and we believe that this approach can potentially address the waning antimicrobial activity during microbial evolution. Thank you so much for listening.
Thank you so much, Ms. Ingalia.
Any questions from the co-judges?
What is your plan to identify the metabolites from the bacteria?
Thank you, sir, for that question. We're actually in the process of sequencing the Pseudomonas aeruginosa whole genome sequence. And also we plan to perform, again, the experiments and then perform the culture, and then we harvest the compounds by extraction. And then we perform mass spectrometry to an HPLC to get the compounds, and then use metabolomics to identify and validate it through mass spec and NMR. And then we're gonna compare it with the genomic data so that we can identify the elicitor compound. I mean, comparing the monoculture and the co-culture samples, of course.
We have still time for another question. 1 minute left.
Do you have to always co-culture it to be able to express its activity?
As we observed po, ma'am, based on our experiments, at first they are able to express the phenotype that we want. They have antimicrobial activity, but prolonged laboratory co-cultivation, as you culture them in the lab without the chemical cues in the environment, the phenotype of the antimicrobial activity is lost. So we tried the co-culture method wherein in our hypothesis that the natural environment wherein there are a lot of chemical cues from other microorganisms, it actually allows the shipworm symbionts to produce this antimicrobial compounds. Yes.
Do we still have time?
Do we have time?
10 seconds. All right. And I think that's a wrap for
Thank you so
finalist
much.
number 1. Thank you very much, Ms. Paula
Thank you
Camille
so
D.
much.
Ingalia. Thank you. Up next, finalist number 2, Ms. Flor Marie Emmanuel R. Pilapil Amante. A round of applause, please. Timer's ready. And your time starts now.
Okay, good afternoon, everybody. I am Dr. Flor Marie Emmanuel Arpilapilamante of the UP College of Veterinary Medicine, and we have a funded research here by the USDA of the Winwak Foundation and the Philippine Veterinary Medical Association Batangas chapter entitled Detection of Banned and Regulated Antimicrobial and Growth Promotant Drug Residues in Hog Kidney Samples from Selected Abattoirs in Batangas, Philippines. Next slide, please. Antibiotics such as nitrofurans and chlorphenicol and growth promotants such as corticosteroids have long been banned in use in animal production worldwide. And here in the Philippines, we have also banned that, but we allow the use of growth promotants, but regulated by maximum residue limits. Next slide, please. And this is due to a public health concern, which can lead to bone marrow suppression, anemia, and cancer in humans. Next slide, please. Which led us to wanting to investigate on the occurrence of these veterinary drugs in hog kidney samples from these selected abattoirs in Batangas, Philippines. Next slide, please. We started with the preparation of this study from September 2023, and we did sample collection and processing in April 2024. Next slide, please. And we were able to collect 41 paired whole kidney samples, specifically 16 from Batangas City, 18 from Lipa City, and 7 from San Jose. Next slide, please. And after 3 days or about a week of the sample processing, we went to the farms to interview the farm owners or the caretakers. Next slide, please. And the results of the study, we were able to get samples from both the commercial and the backyard farms, majority coming from the backyard setup. Next slide, please. And fortunately, we're not able to detect any residues on chloramphenicol. Next slide, please. We were able to test for 4 metabolites of the nitrofurans. Fortunately, 2 metabolites came out to be negative. Unfortunately, 4 came out to be positive, such as AOZ and AHD. Next slide, please. Next, for the growth promotants, we did not detect any residues coming from corticosteroids, steel beans, and trembolons. Unfortunately, we had some positive samples under beta agonists and then ractopamine. Next slide, please. And so with the negative samples, it indicates that there may be non-use of this from the pig farmers already from the 3 selected sites, but we still have to continue with the surveillance and monitoring. And for those that are positive, probably the farmers are still using them in their pig production. Next slide, please. Going forward, we have already started with the cascading of our research results in various stakeholders. And at the end of the month, we plan to pass a policy development on food safety and to be presented to the various stakeholders starting next month and hopefully to be approved and signed by the governor of Batangas by the end of the year and hopefully to serve as a model for the other provinces in the coming years. Thank you.
Thank you so much, Merit. 3 minutes. Thank you so much, Ms. Flor Marie Emmanuel Arpilapil Amante. Now, time for our judges to ask questions. 2 minutes.
Yeah, thank you. First question, why kidneys? I mean, some people don't even eat that, but so why not the meat, for example?
We can have high detection of the residues on the kidneys, being it as an organ of the body that serves as serves to filter the antibiotics and then the growth promotants passing through the body.
So that's the levels that you found in kidneys, you expect them to be lower in the fat and flesh?
Yes, they would be lower in other organs such as the kidneys, in the fat, and then in the meat. So the highest would be in the kidneys. So we use the kidney samples.
Is the protocol, did you develop that yourselves in terms of limit of detection and these types of metrics, or are you using a prescribed sort of procedure?
Yes, we were guided by the Codex Alimentarius guidelines and also by the WHO guidelines, especially on the maximum residue limits and the growth promotants.
Because of food safety, is there a plan? Do you have a plan how to mitigate this kind of risk?
Oh
Have you
yes.
thought about it?
Yes. The very basic step right now is to actually increase the awareness of the pig farmers. So we understand and we realize that there is a need to put more trainings and information drives so that at least if they have increased literacy on this, they would not be using this anymore in their pig production.
Have you communicated your results with the proper authorities?
Yes, we started communicating our results by the end of April. We started with the livestock inspectors, with
And
agriculturists, with the
Sorry,
local
Miss
veterinarians.
Miss Pilamante. I'm sorry to cut you short, but the time is up. And thank you, judges, for the questions. Thank you very much, Miss Flor Marie Emmanuel R. Pilapil Amante. Now it's time for our third finalist, Miss Lilian Isabel G. Trasena. A round of applause, please. Ready? Timer starts now.
Good afternoon. I am Lilian Isabel Trasena from the Faculty of Pharmacy of University of Santo Tomas, and I am here to present our study titled The Effect of Tagalog Over-the-Counter Drug Labels on Medication Literacy of Local Residents in Balete, Malva, and Tanawan City, Batangas. Next slide, please. Over-the-counter medicines are drugs that can be dispensed by pharmacists without a prescription. Due to its wide accessibility to the public for self-treatment, medication literacy is important to make health-relevant decisions to improve health outcomes and prevent patient harm. In the Philippines, most OTC drug labels are drafted in English despite the Administrative Order 2016-0008, wherein labels can be in English, Filipino, or both. The lack of Tagalog OTC labels can be difficult when understanding medication label information for those with limited English proficiency and educational attainment. Next slide, please. Therefore, our study's objective is to determine the effect of Tagalog translated OTC labels on medication literacy in comparison to English labels. So the study employed a quantitative, quasi-experimental pre-test post-test design to measure the medication literacy of 41 participants using OTC drug labels drafted in English and Tagalog using a 14-item Medlit RxSE tool, which contains 10 document literacies and 4 numerical literacies. Next, please. Please. Next, please. So here are the sample labels. Next, please. So the study utilized paired sample t-tests to determine the significance of using Tagalog medication labels to improve medication literacy and effect size to determine its magnitude of effect. With an 8.58 t-value and p-value less than 0.001 and an effect size of 1.34 signifies that Tagalog translated medication labels significantly affects the medication literacy of Batangueños. This is consistent with a study by Wilson et al. 2005, as those with limited English proficiency were more prone to misinterpreting medication information. Next, please. Regarding the effect of demographic variables, next, please. Regarding the effect of demographic variables, it was found that gender, education, attainment, and location of residence has an effect on medication literacy. Next, please. Lastly, the item analysis showed that English label had a higher incidence of error in understanding medication labels, as only 48.11% of the questions were answered correctly, having difficulties in the use, contraindication, timing, and dosage. Next, please. Which contrasts to the Tagalog counterpart, as 67.42% of the questions were answered correctly, showing increased comprehension in multiple sections of the labels, specifically the dosages and appropriate use. Next, please. The study concludes that language localization increases medication literacy and highlights the influence of multiple demographic variables. This supports the promotion of multilingual labeling to improve
And
public
time
health
is up.
coverage.
Sorry. Miss Lilian Isabel Trasena. Time for the questions.
Thank you. My first question is, this seems to be very intuitive, right? I mean, if you put it in Tagalog, they will understand it better. But what about non-Tagalog speaking regions? Have you looked at that?
Actually, we focus first on Tagalog kasi, because it is the most spoken language in the country. So actually, it is in our recommendations that we explore other language to determine the level of need for other types of translation. But definitely, it is one of the recommendations that we recommend to expand local language translation of medication labels.
Anyone else?
Have you considered the accuracy of your translation? Because particularly some of these are medical terms.
We consulted with a language translator to verify if our translations were accurate and if yung the sentences or the mitigation information were translated correctly from English to Tagalog. And um, And we also utilize technical translation, which is basically literal translation of the text, which we did not change much about the information, not too much from the original or the English translation.
Thank you.
All right. Thank you very much, Miss Lillian Isabel G. Trasena. Up next, we have finalist number 4, Miss Audrey May V. Aureliaza. A round of applause, everyone. Thank you. Are you ready?
Hello. Okay.
All right, timer starts now.
Good day. So our research is about the development of M&M Plus, a tapay-based nutrient bar enriched with mung bean and moringa. Next, please. So malnutrition remains a serious public health concern in the Philippines, particularly among young children. Next. Please, next. So we explored developing nutrient bars, and in our study, we focus on utilizing nutrient-rich local ingredients, which are tapay, mung bean, and moringa. And the most important or key aspect of our nutrient bar is the use of tapay, a traditional Philippine fermented rice. So in developing our nutrient bar, we first perform a market study. Next, please. And based on the survey, consumers prioritize taste, nutrient content, and price over the other attributes when purchasing nutrient bars. Next, please. And as to the product profile, consumers generally prefer sweet, chewy snacks in bar form. Next. So considering these preferences, we then profiled our 3 main ingredients. Next, please. And based on the proximate composition, we see that tapay row will have lower carbohydrate content as a result of fermentation. But we can notice that it has high protein, fat, fiber, and ash contents, which may be crucial in developing a rice-based nutrient bar. And also, we see that mung bean and moringa are also rich sources of carbohydrates and proteins. Next. So we also profile our tapay, which we dry, and found that the best condition is drying at 60 degrees for 26 hours. Next, please. So after checking our ingredients, we then proceeded with the final product formulation and analysis. Next, please. So in here, we mix the tapay powder, water, oil, and salt with mung bean and moringa at different ratios. Next, please. And after baking, we found that adding mung bean and moringa significantly increased the protein content of our nutrient bar with the optimal ratio of about adding 10% mung bean and 0.75% moringa. Next, please. And its proximate composition provides a rich source of carbohydrate and protein. Next, please. So finally, we then calculated the calorie content of our nutrient bar and found that it's suitable for a wide range of age groups, and that it is best suited for children aged 3 to 5 years old because it contributes a third of their daily running. Next, please. So here we develop a promising, energy-rich, locally sourced nutrient bar for Filipinos, which we call M&M Plus Nutrient Bar. Next, please. And in our future works, we will do these activities in order to ultimately manufacture a product that gives not just nutrition, but also culture in a bar.
And time is up. Sorry, Miss Audrey May V. Aureliaza, and thank you for sharing your presentation. Questions?
Thank you. You're calling it M&M,
Yes, po.
right?
M&M
And if you
Plus.
plan to commercialize it, I think you're going to have a problem with the Mars Corporation in the US. They are very particular about branding, so you may want to change the name.
I
The other
understand.
thing is, how do you plan to scale up production of this bar?
Honestly, we're still at the last phase of the year 1 of this project. So that part for the scaling up will be in talks in the year 2 of the project. But for now, based on the discussion among the members of the group. We are already in talks with the local farmers for our moringa and mangbin, and also our share stakeholders in Mindanao for the tapay production. So coordinating all of these would help us in the scaling up of our M&M Plus nutrient bar. Thank you.
Can I have one more? Since this is a nutritious product,
Yes.
how would you plan to improve it so that you cover a wide range of, demography?
Yes. So because I did not finish my talk, well, some of the applications that we listed for this M&M Plus nutrient bar is first for the it could be an offering to the children, so we could add this to their feeding program. That's one. And another one is it could be developed as an emergency food during disaster. So we could talk with the government in order to provide it to everyone who is in the shelter during disaster. And then since it's a nutrient bar, it is also considered as a ready-to-eat product. So
And
basically,
thank you very much, Miss Audrey Maybe Aurelia. So sorry to cut you
Thank
short. 2 minutes is up. All right, a round of applause for Miss Aurelia. Up next, we have Miss Janina M. Guarte. A round of applause, please. Are you ready? Okay, timer starts now.
Good afternoon, everyone. I am Janina Guarte, and today I'll be presenting you my study entitled Nice for Gut, Development of Carabao's Milk into a Functional Cheese Food Product. Next slide, please. In the Philippines, Carabao's milk is a promising avenue for high-quality dairy products. It has higher nutritional content compared to goats and cow's milk. However, industry challenges like oversupply and milk spoilage during the surplus season, as well as short shelf life of Carabao's milk products, are hurdles to its widespread utilization. Next slide. We aim to address this challenge by converting Carabao's milk into nice for gut semi-hard aged cheese. Next slide, please. Next slide. So for the starter culture, we used our lab isolate lactic acid bacteria IRL 1401 for its ability to inhibit Shigella, which is the causative agent of shigellosis. Next slide. Next, we developed a small-scale cheese production process with our food science collaborators. Next slide, please. After 3 months of aging, 75 participants showed positive consumer acceptance, implying market potential for our aged cheese. Next slide, please. In our antimicrobial assays, our cheese inhibited Shigella's infective dose with just 0.01 grams. Next slide, please. During the 3 months of aging, the starter cultures that were recovered stayed at 10 to the 7 to 10 to the 8 CFU per gram, which is above the therapeutic minimum of 10 to the 6 CFU per gram, meaning they integrated well into the cheese. Next slide. We also tested the cheese in simulated gastrointestinal conditions and found that it retained our starter culture's viability. The cheese's stable structure and high fat content suggests that it's an effective probiotic medium. Next slide, please. The nutritional analysis indicated that our cheese has 415 calories per 100 gram, making it a high energy food. Then after 3 years of refrigeration, it stayed uncontaminated. Next slide, please. Lastly, our chemistry collaborators, metabolomic profiling of Nice for Gut found 3 significant compounds with good spectral matches to databases with probable biological significance to health, namely melibiose, phenylalanine, and FIPRO. Melibiose suggests prebiotic activity, phenylalanine affects mood and cognition, and FIPRO has various physiological functions, including inhibiting the growth of antibiotic-resistant bacteria and fungi. Next slide. In conclusion, we produce Nice for Gut aged Carabao's milk cheese, combining Carabao's milk benefits with probiotics, making it a valuable functional food. It offers enhanced nutrition, therapeutic potential against gut pathogens, and boosts the economic value of Carabao's milk in the Philippines. So before I end, I'd like to thank Pissured YIP for funding this research, our collaborators from Food Science and Institute of Chemistry, and of course my lab IRL for persevering with me in this venture. Thank you for listening.
Thank you so much, Miss Guarte. And now time for our questions.
Thank you very much. I love cheese. So this is very interesting to me. Also, I wonder if you know that water buffalo milk is actually the milk of choice for mozzarella cheese. They even try to import water buffaloes or carabaos to Italy just so they can get the milk. So that's good. I noticed that when you tested your I don't is that sensory testing or something, it shows that the lowest score is actually crumbliness. How would you how would you correct that?
So for the cheese production, we collaborated with a food tech student from our College of Home Economics. But one of our ideas was maybe to incorporate yeast or uh, modify the production process a bit to improve, to avoid the crumbliness part. But for that area, it's her expertise since I am the microbiology counterpart.
Have you tasted a lot of other cheeses and compared what this tastes like to some of those that you've tasted?
Okay, so last night I tasted a few cheeses from Bonitos. So they are very delicious. For our cheese, actually we need to improve the sensory because it's a bit lightly salty, but I think we can improve more the sensory. Uh it's a bit bland at this stage. This is our first prototype. So I think we can improve the saltiness and the creaminess in that taste aspect. So maybe we plan to add other starters to improve the taste.
All right. All right. Thank you so much, Miss Guarte. That's it. Up next, we have finalist number 6, Mr. Ralph Bernoulli A. Ramos. A round of applause for him. Ready? And timer starts now.
Good afternoon, ladies and gentlemen. I want to share some interesting news from our lab. Next slide. Today's highlight of this work include 3 points. First, our team has formulated a prebiotic supplement at pilot scale that can reverse stunting effects on mice. Second, the supplement comes from whey, which currently has no economic value in Philippines. And third, the transformed product is affordable. And I'm excited to walk you through these points. Next slide, please. Let's start with our process scheme. The main idea in our supplement production is to keep it simple. Thus, we only employ straightforward physical methods. This is quite logical because whey is already nutritious since it comes from whey and it is rich in organic functional compounds. However, there are concerns about utilizing whey because it contains high amounts of lactose and salt. To address this issue, we use ultrafiltration to separate lactose and salt and recover functional organic compounds such as sialylated oligosaccharides and glycoproteins. We have determined these prebiotic compounds in our whey supplement by LC tandem MS and SDS pH analysis. At this point, I can say that we were halfway done with offering a solution to solving malnutrition problems. If we just remove water, then we can get a powder. So the next challenge aside from effectiveness is cost. Next slide, please. The key to resolving the cost issue in the water removal process is cryoconcentration, whose setup is very simple. So I would be glad to talk more about it later if you are interested. The main feature here is that we were able to reduce water content by 5-fold before freeze drying without applying heat. We wanted to operate at low temperatures to preserve the functionality of prebiotic compounds. And indeed, we have shown in the in vivo study of our prebiotic whey powder to reverse the impaired growth in stunting mice models. Next slide, please. If we put into a bigger picture the things that we have done so far, this study, the underlying framework, whey is actually detrimental to environment and we dispose of, which is currently the practice now. So next slide, please. So now it begs the question, how is this important? So consider the case of the milk feeding program under the Masustansya Pagkain para sa Batang Pilipino Act. So the pricing would be quite significant. So under our study, piso lang po ang powder namin compared sa 20 pesos na ino-offer ni PCC. Okay, so in conclusion, next slide please. This proof of concept demonstrates that the Philippine dairy industry can be transformed into sustainable circular economy with a potential key in addressing malnutrition in our country. And here are some points supporting that claim. Thank you very much.
Thank you so much, Mr. Ramos. And now for the questions.
Thank you. Are you aware that you can get ricotta from whey proteins?
Yes, ma'am.
Okay, and that would be an additional product, right? That you should think about, because when I make lasagna, I put ricotta. That's a great product. And whey proteins are also, I mean, if you go to a health food store, whey protein, you will always see whey protein powder. So you actually have several products that you can generate from this. I guess that's not a question, but I'm just saying.
So, so in the US, whey is actually more expensive than the cheese. So it's already a very valuable product. How do you get around the fact that it's actually more valuable to serve it as whey than anything else?
Actually, sir, there's no economic value yet here in the Philippines. So actually, our source is PCC, and they just throw it out and dispose of. So actually, it contributes to the environmental problem. So now we thought of the idea to transform this way. So that's one of the problems. So that's the gap. And then we believe that the whey powder that is commercially available right now, it is different from our whey powder. So, I mean, due to processes, of course. So the invention here is basically on the process part.
Anything else from the judges?
Or you are actually, by doing cryopreservation, you are actually preserving a lot of the important products from
Yes,
whey.
ma'am.
So
Yes.
are you planning of
Okay.
understanding how to commercialize or how to make it more available to
Yes.
Uh,
So,
consumers?
yes.
Sorry, sorry, ma'am. I'm sorry to cut that short. I think I would also love to know the answer to that, but maybe later on. That's it for your spot. Thank you so much, Mr. Ramos, for sharing your work with us. Up next, we have finalist number 7, Miss Jaira Naval Y. Bamba. A round of applause for Miss Bamba. And are you ready? Timer starts now.
Hi, today I want to share an exciting advancement in material science, specifically self-healing technologies. You might wonder, what exactly is self-healing? Imagine if your car could repair its own scratches or your phone screen could mend itself after a drop. That's the kind of magic we're aiming for, but applied to materials used in electrochemical processes. Next slide, please. Our study focuses on developing electrocatalysts for water electrolysis, which is crucial for producing clean hydrogen. Water electrolysis is an environmentally friendly method that uses electricity to split water molecules into hydrogen and oxygen gas. This process usually takes place in an electrolyzer, which typically consists of 2 electrodes immersed in an electrolyte solution and catalyst to speed up the process. Next slide, please. The goal of our study is to make these catalysts efficient with high activity, low cost, and exceptionally stable through a self-healing mechanism. To achieve this, we used earth-abundant metals like nickel, cobalt, iron, and molybdenum to synthesize our catalyst. Next slide, please. Through material characterization, we were able to confirm that we synthesized our targeted compounds, which are nickel 2 cobalt iron layered double hydroxide for OER and nickel molybdate for HER. Next slide, please. Through electrochemical testing, we confirmed the high activity and self-assembly of our catalytic layers in a bare nickel foam substrate during electrolysis because of the electrostatic attraction of oppositely charged catalyst particles and nickel foam surface. The self-assembled catalytic layers exhibited low overpotentials of 273 millivolts for OER and 180 millivolts for HER, which are also competitive with other activities of catalysts presented in the literature with the same materials. Next slide, please. On top of that, we found that they regenerate or reattach on the or the nickel foam electrode as long as there are oppositely charged catalysts suspended in the electrolyte solution. The self-regeneration due to the electrostatic attraction resulted in remarkable stability, which lasted for over 10 hours at high current densities, which is necessary for large-scale applications. Next slide, please. In simpler terms, our catalysts are not only highly active, but they are incredibly efficient. They heal, adapt, and maintain high performances without the need for extra materials needed compared to traditional methods. This innovation could significantly reduce costs and improve the durability of catalysts used in water electrolyzers. So next time you think of self-healing, remember it's not just about futuristic gadgets. It's happening now in the very materials that might one day power our world sustainably. Thank you very much.
All right. Thank you so much, Ms. Bamba. And now for the questions.
Thank you. Did you actually test this on hydrogen generation? And did you see an increase in hydrogen generation when you have this modified catalyst?
For now, ma'am, we were only conducting half cell testing, but in the future, we'll definitely conduct full cell testing wherein we incorporate our oxygen and hydrogen catalyst in the electrodes.
Have you done an energy calculation? And do you know what the efficiency or what the energy loss is of the transformation?
Not yet, sir. We are not yet conducting energy testing.
Well, what do you think it's going to be? Because otherwise you're putting in, if you put in more energy to create hydrogen than you're actually producing, then it's not a very good.
Yes, sir. In the future, we will conduct testing to test the Faraday efficiencies, and we will use DEMS to measure the hydrogen produced from our catalyst.
And have you measured things like turnover number of the catalyst?
Sorry, sir. Could you repeat that?
What are the turnover numbers of the catalyst?
We did not yet include the turnover frequency from our study.
And how would you do that kind of a
We will use
measurement?
electrochemical testing for the turnover frequency.
Any other questions? Thank you.
All right. Thank you so much, Ms. Bamba. And last but not the least, Mr. Honesto Ovid Esto Balinal, our last finalist for this segment. Ready?
Yes.
Timer starts now.
Hello, I'm Ovid Tubalinal. I will be presenting this green hydrogen study. Next slide, please. Next slide. Fossil fuels contribute to 77% of the Philippine energy mix, and the promise made of the Philippines to reduce emissions by 75% by year 2030 magnifies the need to transition to renewable energy and sustainable alternative fuels. Green hydrogen is a clean fuel that can replace fossil fuels, but we do not know how much it will cost when produced locally. Next slide, please. Green hydrogen is produced using electrolyzers powered by renewable sources such as solar and wind. Three electrolyzer types were considered, namely alkaline water electrolyzer or AWE, proton exchange membrane or PEMEC, and solid oxide electrolyzer or SOEC. These electrolyzers have different performances and costs. Next slide, please. To evaluate the levelized cost of green hydrogen, defined as the total cost incurred over the project lifetime divided by the total amount of hydrogen produced, cost and other techno-economic data, resource availability, along with geographical information systems and microgrid simulation software were used. Projections to year 2030, sensitivity analysis and uncertainty analysis were also performed. Next slide, please. LCOH was calculated for all provinces with representative locations for each province selected on the basis of the amount of incident sunlight and wind speed. AWE systems were predicted to yield lower LCOH due to its cheap capital and operating cost. This also implies that the higher efficiencies of other electrolyzers are not enough to compensate for the high costs. The most competitive value for solar-powered systems was predicted to be $5.95 per kilogram in Pangasinan. For wind, this is $3.93 per kilogram in Batanes. These values are much higher than the target $2 per kilogram to compete with the fossil fuel-based hydrogen. Next slide, please. But increased research intensity induced by the higher research and development funding can potentially close this gap in 2030 compared to the base business as usual scenario. Sensitivity analysis reveals the necessity for extreme levels of subsidy when only focusing in one component. Although if you combine these reductions, you can essentially reach a competitive cost for hydrogen. Next slide, please. For the uncertainty analysis performed through Monte Carlo simulations, locations with more resources are characterized with lesser response to randomly variative costs, hence indicating higher economic efficiency and lesser risks. Next slide. Next slide. Next slide. In summary, electrolyzer technologies are still commercially immature, which hinders green hydrogen competitiveness. This implies the need for huge investment in hydrogen technologies for a more cost-efficient production of green hydrogen. Lastly, economic favors such as subsidies, carbon tax, and lower interest rates are also needed to force the competitiveness of green hydrogen. Next slide. Thank you for listening.
Thank you so much, Mr. Tubalinal. And now for the questions.
Okay, maybe I missed it, but if you are producing electricity from solar power, why do you have to produce hydrogen from it? Couldn't you use that directly as a source of power?
Because hydrogen can also be used as a precursor for other cleaners, synthetic fuels. Hydrogen can also serve as a energy storage, can also serve as an energy storage for renewable energy for future use.
So, so you're taking wind power and you're storing it as hydrogen.
Yes.
How does that compare with storing into a battery? What are the efficiencies of hydrogen storage versus battery storage?
We actually have some calculations that reveal that battery storage is still more cost efficient compared to hydrogen technologies. But the good thing about hydrogen is that you can store hydrogen for future use, and then you can also transport it to other, and there are also, again, other uses for hydrogen. So it's a very flexible compound.
So what are other possible uses, especially if you're trying to extend the efficiency of your technology?
Pardon.
Where can you also apply it? I mean, the
Green
technology,
hydrogen.
yes.
Yes, you can use hydrogen to produce ammonia, the green ammonia, which can be used to produce fertilizers, yeah, and other, again, hydrogen-based fuels. You can also use ammonia for energy production because ammonia is much easier to transport because it is in liquid form compared to hydrogen, which is gaseous.
Okay, time is up. All right, a round of applause to all of our finalists for this rapid fire presentation. And of course, thank you very much to our esteemed panel of judges. That concludes our rapid fire presentations. Once again, a round of applause to all of them.
I have a question. Did we miss one?
We only have 8. I think there was a little problem with the last finalist, number 9.
Oh, okay, so yeah. The one by Honesto Tubalinal. Tubalinal is not here. Oh,
That's Honesto Obi
So,
Tubalinal.
Kevin is missing.
Yes.
Okay, thank you.
Thank you so much. Once again, a round of applause. And that again concludes our rapid fire presentations. Thank you very much to our finalists and judges for that very exciting segment. Before we proceed, we would like to remind all of our participants to please sign the registration form. I know you're tired of hearing this, but you really have to sign the registration form at our booth near the entrance. And of course, please do not forget to accomplish our evaluation form for days 1 and 2 using our QR codes. You may scan the QR codes for our evaluation forms at the back of the program brochure, or there you have it. You may scan the QR codes on our screen. Okay. At this juncture, are we ready? All set for the next segment? We will now resume our program with the plenary session to be moderated by Dr. Mariano Santo Domingo, PAASE ex-officio member. Once again, a round of applause to Dr. Mariano Santo Domingo.
Maraming salamat. Magandang hapon po sa inyong lahat. Our final plenary scientific session features the Balik Scientist Program, an initiative of the Department of Science and Technology. So we will start with plenary session L, which focuses on empowering innovation through the DOST Balik Scientist Program. We are honored to have Dr. Lea Buendia, Undersecretary for Research and Development of DOST, who was recently elected as Vice Chair for the Asia Pacific Group of the United Nations Commission on Science and Technology for Development. Please welcome Dr. Lea Buendia, ma'am.
Good afternoon, everyone. Nice to be here and looking at the members of PAASE coming from all over the world, actually, coming maybe not only from the US, but I'm very glad to be here this afternoon. And thank you for inviting the Department of Science and Technology and partnering with PAASE. I think PAASE is one of our partners where we have the most scientists and Balik scientists so far. Okay, so allow me to introduce to you, of course, with the number of Balik scientists. Maybe some of you have not yet experienced being a Balik scientist. And I think this is one of my way to promote the Balik Scientist Program of the Department of Science and Technology. I think I need to have my slides. Okay. As you very well know, the Balik scientists started off as early as 1975. Maybe some of you have not yet been born by that time, but there is already a Balik scientist since 1975. And this was started by the then late President Ferdinand Marcos, so that in the last, maybe the other year of the Balik Scientist Convention, the son, the President Ferdinand Marcos Jr., graced the occasion of the convention of the Balik Scientists. And this was through a presidential decree. However, in you will notice that in 2018, the Balik Scientist Program was approved as a law, which placed some teeth on how we implement the Balik Scientist, and also providing some additional incentives for it to be more attractive to the scientists. And during that time, we have the rules, the implementing rules and regulations crafted. And this was a good avenue for the Balik Scientist Program to be part of the whole ecosystem of the scientists. So the Balik Scientist Program actually is a strategy for the brain game of the Department of Science and Technology. Since during that time, as early as 1975, most of the scientists are going out of the Philippines to look for greener pasture. And I think even now, if there is an opportunity for scientists to go out, they go out. So we don't see this as a disincentive to the country. Rather, we see this as an opportunity where the Balik scientists can gain more insights, experiences, and knowledge, and even technologies outside of the country, which will allow them, when we engage them as the Balik scientists, to share these technologies to other Filipinos and other researchers in the country. We find that the Balik Scientist program actually can focus on several priority areas, which are actually crucial for the country's progress, particularly on agriculture, on health, the industry, energy, and even emerging technology. So by targeting these key sectors, the Balik Scientist program actually seeks to harness the knowledge and skills that the returning scientists have, even their networks. So we bank also not only on their activities, nor on their knowledge, but even on their networks. So through these collaborative efforts with other government and academic institutions and the industry partners, the program actually created a conducive environment for scientific advancements in the country. So the BSP components actually are two. One would be the Balik scientist, but the Balik scientist will not be here if not for the host institution. The host institution actually requests the Department of Science and Technology for them to be able to access or engage a Balik scientist. So the host institution may either be a government agency, a local government unit, or even private sector. In this case, we have several already of these kinds of engagement. So even our local government units, we have previously had maybe 2 local government units engaging a Balik scientist. One will be on traffic, and another one is on, I forgot, but there's another one that hopefully solves the issues that besets the local government units. So that there are actually 3 types of engagements of the Balik scientist. The short term, the medium term, if I may go back to the short term, the medium term, and the long term. The short term, these are the incentives that we will provide the Balik scientist. The short term ranges from less than 1 year, 15 days to 6 months in essence. And the medium term is from 6 months to 1 year. And the long term is actually a different situation whereby it is the Balik scientists should be here from 1 year to 3 years, and then they can be engaged on a long-term basis. But a host institution should hire them for good. And I think Dr. Serafica is nodding his head because he is one of those long-term Balik scientists that we have. So these are just the incentives. For the short term and the medium term, we have a 1 round trip ticket coming here and going back to their area of work. And then daily allowance of about $200 per day. Mas okay po ngayon kasi mataas ang exchange rate. So magbalik scientist na po kayo habang mataas ang exchange rate. And then, of course, participation in our grants and aid program, they can assist our host institutions to do some work on research and development. And of course, the long term, we have one way airfare exempted from tax, and then we have a special relocation benefit because they will be staying for good of about 40,000 per month, and admission assistance of all their dependents. We have the eligibility requirements, of course, because this is government funding. We have to follow COA rules, the accounting rules, but I think this is one of the easiest when it comes to implementing implementing a program. It's not really no questions asked, but less questions asked from COA and accounting. And these are just the eligibility requirements. You may not be a Filipino citizen as of the moment, but even if you were naturalized, but you have Filipino descent, even if you were not born here, but as long as you have Filipino descent, like your parents, your mother, or your father, you can be eligible for the Balik Scientist program. And of course, you must be an expert in your field. Otherwise, you may not be called a Balik Scientist if you're not an expert in your field. And must not have any unfulfilled obligation. Meaning, yun pong hindi na bumalik after their PhD, may service obligation sa university dito, hindi po siya pwede unless fulfilled po yung kanyang obligation. So it's very easy to join the Balik Scientist. So far, what have been done and what were the accomplishments of the Balik Scientist program since 1975? After the signing of the program into law, the Balik Scientist program engagement shoot up. Why? Because we can now offer incentives. Dati po gratis, halos gratis. So we cannot encourage our scientists to come back or to visit or be engaged in our programs. But after the law has been implemented, we are fortunate enough to have a very big engagement when the law was enacted. And this was actually also a good time because this has been that the president, no other than the president, have provided his support to the Balik Scientist program. And the number, you will see that the number of Balik Scientists from 2018 after the law has been signed, it shoot up in 2019. However, we had COVID, so the number of engagements dropped. However, we did some changes to adapt to the current situation in 2020. We allowed online Balik Scientist engagements until about 2022. So there were online Balik Scientists, particularly when the time that we were doing the Virology and Vaccine Institute of the Philippines. We had 7, and of course, Dr. Ilag is here, who helped us a lot in coming up with the bill on the Virology and Vaccine Institute. We didn't know anything on how to proceed, but because we have these experts, they helped us in doing and in crafting the bill. You will notice that insofar as the program is distributed, this is the distribution. We have the most number, of course, Region 4A, not because we are here, but because I think there are a lot of institutions within the Region 4A that requests that requested our assistance when it comes to the Balik scientists. But you will notice that even in as far as Region 12, Region 9, Region 10, Region 13, there is a presence of a Balik scientist. For the monitoring and evaluation of the accomplishments of the Balik scientists, you can see that we have been promoting this as far as engaging ourselves whenever we travel, engaging ourselves with scientists there and promoting the Balik Scientist program. We also are being helped by our permanent missions and our Philippine embassies to locate the Balik scientists, the possible Balik scientists. And with this, these are just some of the activities that have been done by the Balik scientists. Publications, you will notice that in 2023, we have 214 publications that have been supported or have been engaged by the Balik scientists together with the host institution. And technologies introduced, we have 256, which are not actually not patented, but at least the technologies have been transferred and now is being used by the different host agencies. We have, of course, trained the Balik scientists, help train, mentor, and even support the young scientists that we have. This is in the number of 377 people services, but we have about 19,000 people trained. And of course, partnership. This is not only partnership within the Philippines, but the Balik scientists have introduced and linked us with their partners as well outside of the Philippines. So, well, this is just another way of showing it. But these are just some success stories. Some of the Balik scientists, I cannot name all the Balik scientists, but these are just some of them. Let's begin by looking at the works in the field of food security. Because Dr. Ebora is here, I started this off with food security. I know this is his turf, Los Baños, so our Balik scientists have been at the forefront actually of developing innovative solutions to ensure that our population has access to safe, nutritious, and sufficient food. Dr. Lucob Agustin discovered a drought-resistant rice mutant called WEG1. In her study, she discovered that the mutant developed highly branched root systems and survived adverse environmental conditions. And this can actually significantly enhance resilience of agricultural systems, promoting actually food security and improving access to food. The next one is the success story of who else but Dr. Homer Pantua, who is here sitting there and is a long-term Balik scientist as well. The COVID-19 pandemic, together with the African swine fever, devastated the whole country in 2020. Up until now, I think the African swine fever is still causing some problems. So this guy, Dr. Pantua, who is born and raised in Los Baños, is the one who established the first ever Filipino-made mobile biocontaminant laboratory. There are already 3 of them currently, and this one was a health diagnostics launched by the Bioassets Corporation, who he also established. Dr. Pantua has also been part of the Virology and Vaccine Institute of the Philippines, together with Dr. Ilag. They are 7. There was 7 of them during that time who helped us out in this one. And of course, Dr. Pantua still discovers a lot of other things aside from this mobile laboratory, and also gaining popularity by having awards with these inventions of him. The next success story is our Balik scientists who contributed in the realm of health and nutrition. So I was telling you earlier, there were seven Balik scientists who have been working with us in the Virology and Vaccine Institute even up to now. Hindi na po sila engaged as Balik scientists, but their heart has been there for the Filipino. And of course, one of which was Dr. Nadala, co-founder of the Diagnostics for the Real World, or the DRW, who led the development of the rapid diagnostic tests for HBV surface antigen, the HIV antibodies, the HCV antibodies, and the improved CE mark test. So in February 2020, actually, his team developed the Samba2 SARS-CoV-2 tests in 2 months' time. So now it is used in 79 UK hospitals and schools with 648 assay modules and 300,000 tests deployed. These efforts actually is part of the broader initiatives bringing Filipino scientists back to the Philippines to help us out. Another one is the success stories of Balik scientists together with young researchers from the Western Visayas University of San Agustin. Sa USA din po sila. Galing silang USA, pumunta po silang USA. But this time in the Philippines. So they discovered new species potentially containing antibiotic and anti-cancer properties from the Tubataha Reef, a national park. And beyond all of this, I think Dr. Junel and Dr. Dalisay has been partnering with the private sector to upscale their discoveries. One will be on skincare, and another one will be on potential novel antibiotics. Dr. Jonel Saludes, sabi niya po sa akin, iniwan nila po ang US with 6-digit income. So I asked them why. Why reside in the Philippines after all of these things? I think it was because of their love for the Philippines. And they want to see their relatives here and stay with their relatives here. And to be also as productive as they are in the US. And so Dr. Junel Saludes, in partnership with a local pharmaceutical company, who is also a beneficiary of our Grants in Aid program, and very young at that, Galen X, is one of the pioneers of the first bioprinting laboratory, which is a breakthrough in dermatological products. So both Dr. Saludes and Dr. Dalisay with their team in University of San Agustin has been pioneering several research activities such as the NMR, the CANMEET, and all the other laboratories that have been built out of the proposals that they have been doing, and DOST providing all of this support. Another result of the Balik scientist engagement were actually the pride of having received a lot of awards and engagements after even those activities that they have done as Balik scientists. So they have heed the call of the Balik Scientist program and heed the call of a country in need. So what's the future direction of the Balik Scientist? For 2024, the program actually targets about 55 more Balik scientists coming in. I was asked by the Senate in one of the budget hearings, could there be one Balik scientist for every province? I said yes. As long as you give us the funds, we can find a Balik scientist that can be assigned for even for every barangay that you need, we can. So I think this is a challenge that has been called to improve on the engagement of the Balik scientists. So this April 2024, we have improved the guidelines on the provision of incentives, the grants and the awards of the DOS Balik Scientist program. So now the Balik scientists can actually give in their proposals and can implement projects under the DOST. So as I am about to end this presentation, I would like to call on the Balik scientists to be our ambassadors outside of the country, but even within the country. So I'm calling you to be a Balik Puso, Balik Pilipinas, Balik Scientist. Magandang hapon po sa ating lahat.
Thank you very much, Yusek Leia. Thank you for DOST and your continued commitment to support Filipino scientists overseas who would like to serve the country through their science. Please take note that there are certain regions in the country that still needs Balik scientists, and presumably those are the some of the poorest regions. So Yusek Leia and her team were in the United States early this year and also in May to promote Balik scientists, and PAASE has been a strong supporter of the program. So for our next plenary session, we will continue with the topic food security and sustainability from the sea. We are honored to have with us Dr. Leo De Vico Ilag, Non-Executive Director of Plantex Limited. Dr. Ilag is a scientist and biotech entrepreneur with 30 years of experience in the R&D and commercialization of platform technologies, antibody-based therapeutics, complementary medicine, and diagnostics in Germany, Australia, and the US. A round of applause for Dr. Leo Ilag.
Thank you very much for the kind introduction. Yep. Oh, by the way, I'm born and raised in Los Baños. I'm a native. I've lived here about the first 17 of my 20 years. So for the past 40 years, I lived outside of LB, but spent most of my Christmas in LB. So what I'll be talking about today is food security and sustainability from the sea. Even though Doc Leia, Yusek Leia mentioned about being VIP, there's nothing virology about what I'm going to talk about today, but my affiliation with a company called Plantex Limited. So Plantex Limited is an Australian company. It's a bit of a unique situation. So just give you a bit of background how I ended up in this company, although I'm based in Australia. So about 10 years ago, I had to move back to the Philippines briefly because my aunt who took care of us when we were young had a stroke. So I spent 4 to 6 months here. And then on the way back, actually because of that, I lost my residency, a continuity in residency. Therefore, I didn't qualify for my Australian citizenship. And my wife and daughter were able to get it. So whether that's by serendipity, I'm still 100% Filipino to this day. Okay, so thank you. So Plantex Limited, we're an Australian company, unlisted, but our operations are actually based mainly in Region 8, in Tacloban. About 10 years ago, as I mentioned, so Plantex Limited was a mining company founded in 1985 and then shifted focus towards aquaculture about 2013. They moved to set up operations in Tacloban. And again, whether by serendipity, Typhoon Yolanda came. So it kind of wiped out all the operations. They had to restart. Coincidentally, at that time, that was when I was moving back to Australia that I was recruited. But we had to do, the reason it's not mainly for aquaculture, but we had to spin out some assets because of the change of business. But Plentex still kept its focus for the past 10 years on building an aquaculture business in the Philippines. And I could tell you, again, this would be a separate session. It has been an experience. It's almost like after getting the operations wiped out, starting from scratch, of building a startup agriculture company in the Philippines. And for the past 10 years, it has been an experience, but that will be for another day. So sorry. So just to give you an overview, so we're focused on aquaculture, mainly two. Main is production of particular fish, tilapia and bangus, which I'll mention that a bit later. And then secondly, which I won't cover well, is we're working on growth of seaweeds, in particular a species which is known to reduce methane, which is Aspergopsis. We've also licensed, and I won't talk too much about that today, and we've also licensed the growth of a particular red seaweed in from the marine science into Talamina, which seems to be a good source for an ingredient for electric batteries. So as you see, for the Philippines is an archipelago. We have a large coastline. We're based on the west side, region 8, mainly Tacloban, but also we've taken over a revamped hatchery at the town of Villarreal. It's a Gintarcan Island just off the coast of Villarreal, the town of Villarreal, and that's where we're building our operations. So what I will be talking about today is more technology which we license from the Philippines and how we're gonna build a sustainable aquaculture business in the Philippines. So as you know, we have a growing population in the Philippines. One of the advantages of the Philippines, we have a young demographic, but that at the same time is a bit of a ticking time bomb because of the health situation of our young working population. Even though we might be young, but we're very, quote unquote, a bit sick because of growing trend of prevalence of obesity and overweight. And this has always been associated with the kind of foods we've been eating. So the question then is, how do you feed a growing population nutritious food? So this is the problem, but at the same time, contributing to climate solutions with sustainable global food security. So without harming the environment. Oops. Does that work? All right. So one of the things which has been attributed or at least cited as a way of feeding the population is the growth of aquaculture. So you probably heard reports this year that it's only first time this year that aquaculture has actually exceeded the amount of fish produced by aquaculture over open catch fisheries. In spite of that, we have a growing, we know that we have a growing aquaculture business in the Philippines. However, there is a large deficit in the amount of catch as well as production of fish in the Philippines versus over our consumption. So there is a shortage. So we then therefore really have to import. And how do we address this particular problem? So one of the challenges of aquaculture is that you need more fish to produce more fish. And the major reason for that is it's a cheaper source of protein. So this type of fish which is used is mainly sardines. So whether it's a debate, how do you feed, whether you use that as food or use that as feed. And if you look at these expensive fishes such as bluefin tuna, it really takes about 10 to 20 kilos of fish to produce a kilo of bluefin tuna. You have here below, you have the feed conversion ratio for beef, pork, and chicken. They're relatively high. And then you really see that it's more sustainable to have the other fishes like bangus, tilapia, barramundi, and salmon. But the question is, how do we address this? So there's a shortage, impending shortage of fish for feeds, and there's a debate then how could we then convert this? So you probably heard a lot of alternative fish feeds, such as whether it's from mealworms, black soldier fly, or even some alternative plant proteins. But again, the question is whether those would be healthy. So this is what it has been shown that there are certain requirements for fish meal replacements. So this has been outlined by Ioannis Mavromichalis, and you have to look at the amino acid profile, the storage, palatability, and whether it's a good source of bioactives. So one of the things we found out in the Philippines, and this was discovered here or developed at Tarlac Agricultural University, is a protein-enhanced camote or cassava, which is essentially a biomass from solid state fermentation. And that's what I'll be talking about today. So sweet potato, although it has a negative connotation when mentioned something as camote, it's actually superfood. It also has nitrogen fixing properties, so that's very helpful when you're intercropping it with other crops. It's been identified as a good intercropping plant with coconuts, and 10 to 30% of sweet potatoes actually rejected. So sweet potato has also gone popular as well as because of, I guess, popularity of K-pop and japchae. So the sweet potato flour is actually an active ingredient for that. However, off-cut salt, such as this waste, is actually not ideal as an animal food directly because of the presence of anti-nutrients. So this was technology developed at Tarlac Agricultural University. It's solid fermentation, so it's much cheaper. What they've done is they found a concoction of macrofungi as well as microfungi, and you ferment it in plastic bags. And from this, you could convert sweet potato, which has a protein content of 1 to 6%, about 18 to 40%, mainly from this concoction of macro and microfungi. They've already successfully tested this in pigs and poultry as alternative feed. But when we approached them, a colleague of mine about 6 years ago, we did apply for a USAID STRIDE grant together with Dr. Rex Trafalgar of UP Visayas. And the idea is whether we could completely replace soybean meal and fish meal. So that was tested in different species, bangus, tilapia, as well as P. vaname or white shrimp. At the beginning, I was a bit skeptical about it. I thought it was just a generic study replacement for it, and that's why we went ahead. But one of the things which we discovered with this particular study, which got us excited, or at least I got excited. So this was pretty much standard. We saw that there was an increase in weight, especially for the feed conversion ratio is pretty much the same, whether it's a substitute fish meal or soybean meal. There's percent rate in gain. But the more interesting thing which we found out was this particular ingredient, when substituted, replaces, or the total gut bacteria is reduced, in particular the Vibrio species, as well as the lactic acid bacteria. And it also had some antibiotic properties. And one of the things which was unique about this is that Vibriosis is a common pathogen among shellfishes as well as finfishes. But the most interesting thing at this study, which we found, was the change in profile of the omega-6 fatty acids. So, or the profile of the omega-6, omega-3 fatty acids. Tilapia often has been called as a really unhealthy fish because it's worse than bacon. And one of the reasons they say that is because the omega-6 fatty acid content is very high. And that's mainly because of the feeds that is fed to the fish. And if you're not familiar, so when you say omega-6 fatty acids, so these fatty acids are usually pro-inflammatory, and the omega-3 fatty acids are the anti-inflammatory, especially the long-chain polyunsaturated fatty acids such as EPA, DPA are the major components of your brain as well as eyes, and very important for brain development as well as lowering inflammation. And what we see here is you could see that if you're tilapia, milkfish, and shrimp, the 3 to 6 ratio. So there is actually much more omega-3 per omega-6. A typical Western diet nowadays is actually 20, the ratio of 6 to 3 the fatty acids. And that has actually been attributed to inflammation and most chronic diseases. The reason that's important is if you look at the risk of obesity is associated with the high omega-6, omega-3 fatty acids within the diet. And that's important in low omega maintaining low omega-3 for reducing inflammation. So I think there were talks earlier about stunting. And actually, in terms of preterm birth, if you look at countries with, and there are already published studies, like there was a recent Cochrane review, the deficiency in omega-3 fatty acids could be attributed to high preterm birth, as well as stunting. So that if you could actually increase your omega-3 relative to your omega-6 fatty acids, you pretty much could increase your health, increase the health benefits for it. So this is what we're excited about, that there is the possibility just by shifting. If you look at the sweet potato, fermented sweet potato, there's no other source of omega-3 fatty acids. So one of the things we're not exactly sure yet is the mechanism of how this fermented sweet potato is affecting the metabolism. We know that tilapia is able to synthesize it, but whether this is a factor which actually trigger or shift the balance so that we could then have more omega-3 fatty acids. All right, so the reason I'm showing this, so one of the things I love tilapia as well, but tilapia tends to be a commodity or a really cheap product. And oftentimes it's associated because it's really not healthy or it's tastes like lasang lupa or something in the Philippines. And then you have a qualified, depends where the tilapia is coming from, is actually related to if it's come from Talisay, that it's clean, it tastes better. But there's really nothing talked about the nutritive content. Now, if you look at in terms of the value of tilapia, okay, this is just taken this is years ago, but it's pretty much still the same, the last time I checked. So that's about 13 Aussie dollars. Based on the conversion rate, that's now about 500 pesos per kilo. So a tilapia. So this is from Taiwan, the tilapia. But this is the regular tilapia, which has omega, typically associated with high omega-3, omega-6 fatty acids. Behind there is what you call bara. That's barramundi. That's about, you can see it's like $25. Barramundi is also known to have high omega-3. But if you look at me, or if you ask me, I would actually I prefer tilapia versus barramundi, although barramundi tends to be more expensive. So the point of this slide is whether just by increasing omega-3 content by feeds, are we able to increase the value of this particular fish? Because then will then catapult this to make it as an export commodity for the Philippines. So that's one of the things we're looking at, Plantex. So when you look at the profile of the different fish meal replacements, pretty much this Pro and K ticks all the boxes. So it has the ability, and what's more exciting, I think, at least for me, people talk about soybean meal or plant-based proteins, increasing for a substitute. But the problem people have don't realize that the high omega-6 content of those feeds contributes to the unhealthiness of the particular fish or seafood. So this is just summary that Pro and K is a cost-effective, safe, and renewable protein, and it endows a profile, fatty acid profile that can provide additional benefits. Now, before I conclude, one of the things we're working with, and I'm not sure you're familiar. So I mentioned that there's a large coastline of the Philippines, which is a competitive advantage. One of the problems, though, with the Philippines being our archipelago is the cost of production. So you might have feeds, you could produce it, but then to distribute it to different areas in the Philippines becomes a logistical cost. So one of the things we're attracted to this, and we have some internal discussions on this, is for the Philippines might be a different model how we produce this. But in Australia, it's a landlocked area, we produce about 90,000 metric tons of sweet potato in a particular state. So we have to scale that differently. But in the Philippines, we have to produce it, but that could be already the scale which could be produced currently by Tarlac Agricultural University. Then the last one is, if you're not tilapia, again, based on the coastline, the Philippines has actually developed this Molopicus tilapia by BFAR. So Molopicus tilapia actually is a salt-tolerant tilapia. Actually, it could grow in saline tilapia. It's based on, from studies, what we heard, it has a better taste profile. But interesting thing is that omega-3 content is also relatively higher. So if we could feed that together with Pro and K, we could have a potential product. And one of the limitations of the growing population is tilapia, remember, is fresh water. Fresh water is already becoming limiting. And because of our long coastline, we have an abundant source of marine products that could be tapped, especially for growing aquaculture. That's why we're excited that we possibly tap the use of the Malapicus for fish production combined with Malapicus, with Pro and K. So for that, I thank you for your kind attention and would be glad to entertain any questions later.
Thank you very much, Dr. Ilag. This is such a very important area because of because of the maritime and archipelagic nature of our country. We have one speaker from the University of Rizal system who's interested in actually applying for Balik scientist, and his topic is actually aquaculture. Now, our next plenary session for this afternoon is about advancing functional food research in the Philippines towards the attainment of nutrition security. Our speaker is Dr. Myra Villarreal. She has engaged in cell biology research for 15 years and has authored and co-authored over 40 publications in the field. A DOST PCHRD Balik scientist, Dr. Villarreal has held prestigious positions, including being a research fellow at the University of Montpellier, visiting researcher at the University of Oxford, and associate professor at the University of Tsukuba. She also served as quality control manager at Peter Paul Philippine Corporation and University Research Associate at Biotech UPLB. Dr. Villarreal has prepared a video presentation, so please watch this video.
UST Undersecretary Dr. Leia Buendia, PAASE President Dr. Gladys Completo, Just Santos moderating this session, fellow Balik scientists, speakers, ladies and gentlemen, magandang hapon po. Ako si Myra Villarreal. Recently, I served as a PCHRD, DOST PCHRD Balik scientist. And today, I will talk about advancing functional food research in the Philippines towards the attainment of nutrition security. Philippine foods are considered healthy. We normally or usually use local vegetables. We cook them in healthy coconut oil. We mix it with seafood and moderate amounts of meats, as you can see in this slide. However, if you walk along busy streets anywhere in city centers or even in the provinces, these are the foods that are made available to us and to our children. You can see that they're high in sugar or high in fat and generally unhealthy. If you are well off, you live in cities, you probably would be craving for these Japanese foods that are delicious, but they're also equally unhealthy because they're high in fat. If you eat them more than once a week, you know what will happen. And of course, we have this high fat and high sugar beverages available in every corner in the Philippines, especially in Manila. And at the heart of all this talk about food is nutrition security concern of the Philippines. And there are really two sides to this. And two particular points that we need to focus on in order to address nutrition security. If you look at the left side of this slide, you can see malnutrition there. And every day, 95 children in the Philippines die from malnutrition. 27 out of 1,000 Filipino children do not get past their 5th birthday. And a third of them are stunted or short for their age. And if children are malnourished until the age of 5, this is already irreversible, as mentioned by experts. On the other side of this slide, you can see that a lot of our children are also becoming or increasingly becoming overweight and obese. And nearly 1 in 10 children are obese or overweight. Basically, the Philippine food environment is failing our children. Children are eating fewer fruits and vegetables and more sugar, salty, and fatty products. And 74% of 13 to 15-year-olds eat less than 3 portions of vegetables per day. So who's to blame? The parents or the environment? So this is the report of World Health Organization and the Department of Science and Technology. What is alarming is that parents are also unaware that even their children aged 6 months to 3 years old are actually exposed already as early as 6 months to processed foods with added sugars. Okay, so we buy them as processed food that we thought are good for our babies, but they're already high in sugars. So around 27 million Filipinos are already obese. Overweight and obesity among adults has almost doubled from 20.2 in 1998 to 36.6 in 2019. So that is quite significant. And in the Philippines, that increased rate in obesity also now has resulted to diabetes. So that 1 in 14 Filipino adults, okay, lives with diabetes. And the prediction or the predicted numbers are actually presented in this slide. Our adolescents by 2030 will make up 30% of the adolescents by 2030 will be obese. 30% of them will be obese. And on this right side of this slide, you can see that by 2030, more than 5 million Filipinos will have diabetes, and it will just be increasing. Okay. As you can see here, that by 2045, more than 7 million Filipinos will have diabetes, and that puts a lot of burden to our economy. Obesity or overweight are the key risk factors for chronic non-communicable diseases. And these non-communicable diseases are referred to as lifestyle-related diseases, which means that they are modifiable. Pwede pa natin itong baguhin because the onset and progress of these diseases are related to our lifestyle and our behavior, such as our diet, our physical activities. Do we smoke? Do we drink a lot of alcohol? Okay. And according to the World Health Organization, 67% of all deaths are actually preventable because they are NCDs, so preventable diseases. Non-communicable diseases, for those who are not in the health sector or are not aware, are a group of conditions that are not mainly caused by an acute infection, result in long-term health consequences, and often create a need for long-term treatment and care. It includes cancers, cardiovascular diseases, diabetes, and chronic lung illnesses. The result of a combination of genetic, physiological, environment, and behavioral factors. So what you can see here is that non-communicable diseases result to long-term health consequences. Long-term treatment and care are needed. So what we also need to do in order to address this problem is to think of something that could also have a long-term benefit, because mahaba-haba, long-term din na paglalaban natin ito with non-communicable diseases. It's a long-term fight against these diseases. Okay, and I was made aware when I visited the Philippines for my Balik Scientist engagement that a lot of people are already taking medication for their blood pressure. So a lot of people have high blood pressure, and I guess I was able to escape this when I moved here in Japan, because most of the people here, until they reach the age of probably 70, that's the only time that these people take this medication. So you can see this this discrepancy, this difference between the lifestyle that we have here in Japan and the lifestyle that we have in the Philippines. So the problem of NCDs cannot be solved by the Department of Health alone. Okay, it concerns our health, but this is not something that the Department of Health alone should carry as a burden. So even Spider-Man needed the Avengers to help save the world, right? So if you look at the left side of this slide, you can see the underlying determinants of NCDs, which include poverty and poor living conditions, okay, social exclusion, design of cities and towns, availability and marketing of goods. So poverty and poor living conditions essentially would deprive people of education, knowledge about what foods are healthy or not. And of course, if you are poor, you can afford high salt. You can only afford high salt and low nutrient containing foods. So poverty and poor living conditions, the design of cities, which mean if your cities are not what we call walkable, you do not have parks nearby. So that also deprives you of space for having exercise or just having a place for your children to walk and burn whatever calories they have taken in. And availability and marketing of healthy foods, okay, is also very important because, like I mentioned in the previous slides, what we basically eat are the foods that are available in the neighborhood, what is available nearby, what we can put our hands on. So availability and marketing is very important. So these are the underlying determinants which would promote behavioral risk factors. And then it will result to this intermediate risk factors such as becoming overweight, raised blood sugar or high blood pressure or abnormal blood lipids, and then you have your NCDs. The World Health Organization already gave us this suggestion in 2019, and I think it's about time that we seriously take this and this advice and report into heart and do something about it. So in my case, I will just focus on functional food. That's the only thing that I can contribute to saving the earth. Okay, so what are functional foods? So these are foods that offer health benefits beyond their nutritional value. And when we eat, we don't really think about it, but foods serve three main functions. First is the nutritional value or function. So foods contain vitamins and minerals. And of course, it's delicious, which brings us to the second function, sensory function. It's delicious. That's why we eat it. We prefer foods that are well prepared, masarap. And in 1980s, in the mid-1980s, the Ministry of Education, Culture, and Sports of Japan introduced this third function of food, which is disease prevention function. So foods also have the ability to help us prevent diseases, okay? So this is well-regulated in Japan, although recently there are some problems, but in general, we have foods classified if they are with health claims. So foods with health claims could be foods for specified health uses or FOSHU. So these are scientifically recognized as helpful for maintaining and promoting health and are permitted to bear claims in their label. For example, it slows cholesterol absorption. There are also those that contain nutrients. So remember the first function, which is a provision of nutrients and minerals. So this can also be used to supplement or complement the daily requirements of nutrients. So remember that these are foods that you eat in addition, or probably the main source of nutrients, okay? And there are those that are foods with function claims. So this can be labeled based on scientific evidence, not necessarily done, or the experiments are not necessarily done by the seller. For example, we have bananas from the Philippines. We have bananas here in Japan coming from the Philippines. And they can be sold as foods with function claims by using the data or information in published papers. You don't have to conduct experiments to have this foods with function claims. So you have all this classification. And of course, if you can do something similar in the Philippines, which is a dream of Dr. Jaime Montoya, to have the same kind of regulation for our foods in the Philippines, then it will really be very helpful for those who would like to change their lifestyle. And remember that with foods, these are different from pharmaceutical products and quasi-pharmaceutical products. So just with food, it's not medicine, it's not pharmaceutical. So remember that if we will fight NCDs, this requires long-term solution because NCDs ay mahaba-habang labanan. So functional food, changing our lifestyle to include functional foods is our way of having a long-term solution to this NCD problem. Okay. So again, the benefits and purpose of functional foods is mainly for helping us prevent disease, not to cure any disease. So may cancer ako, should I eat functional food? Yes. But do not stop taking your medication. Do not stop having your chemotherapy because it will not treat your cancer. It will help you prevent it. But if you already have the disease, please continue taking your medication because the functional foods are not medicine. Okay, so I hope that that is clear because there are many information proliferating in social media about people stopping taking their medication because they're eating or taking foods that are good for them and help them prevent disease. So prevention and not cure. Okay. So here are some examples of functional foods, labeled functional foods in Japan. They have the Foshu seal that I mentioned. An example would be for promotion of healthy digestive system. You have yogurt that contains Lactobacillus lb81. You have our favorite Yakult probiotic drink that contains Lactobacillus casei hirshirata strain. We also have those claimed to have cancer and allergy preventive effects. You have this natto, which I think most Filipinos here do not particularly like because of its texture and slimy taste. Excuse me. We also have green tea that contains epigallocatechin 3-orthogallate, proven up to the epigenetics level that can actually help prevent cancer. So I was made part of this research on macilinic acid jelly, food that a functional food developed to target inflammation. Okay, as you can see here, it's effective in reducing inflammation in mice to help prevent arthritis. So for those who are 60 years old and above, who are concerned about arthritis, this is something for you. Okay, so we provided the scientific evidence, and it is now sold in the market here as a functional food, an anti-inflammatory functional food. Of course, we did clinical trials for this and other necessary tests. Another one, my favorite topic to talk about is the purple sweet potato, which is also abundant in the Philippines, especially from the Bicol region, the biggest sweet potato manufacturer. If you look at the analysis of the components of composition of purple sweet potato, you can see that it's high in tricafilcanic acid or cafilcanic acid or anthocyanins in general. And in vivo studies have shown that using senescence accelerated mouse model, okay, so you can see here, it's already an elderly animal, even if they're the same age as the mouse on the left side. Of the memory of the mice, as you can see in the result of the Morris water maze test here. Okay, so they measured escape latency, and mice given purple sweet potato extract were able to escape or reach the safety platform. So that's one evidence. In other experiments that we performed at the molecular level, we have shown that tricafilcanic acid present in purple sweet potato promoted neuronal plasticity. So it promoted the growth of neurons, and other biomarkers were expressed to signify that indeed it's good for the brain. Okay. In the Philippines, we also have functional foods, of course. Of course, we have also purple sweet potato, but studies in the Philippines and purple sweet potato is a bit is lacking, and I think that's something that we need to address. So, but the good news is that an increasing number of Filipino researchers are working to establish the scientific foundation for the efficacy of these foods. And I think the leading group on this particular research are the researchers at UPLB. We have Dr. Gladys Completo, of course, doing her share, and also our good friends at the Institute of Food Science and Technology, Dr. Mopera, Ma'am Katsi, and their friends there. So one of this is, of course, our study on Bignay, okay, which has in vitro lipid lowering properties, and that's reported by Madam Katsi of the IFST. Okay, and they freeze-dried also the bignai and found that freeze drying actually resulted in higher phenolic content and anthocyanin content. Good news, right? Because it means that this freeze-dried bignai can be stored and they can be made into different products. Okay. We also have brown rice. So most Filipinos prefer white rice, but we can also teach Filipinos to love eating brown rice. So our food technologists should develop ways and means to cook this rice so that people will find it easier to prepare this, because brown rice could help ameliorate the metabolic risk factors of NCDs among overweight and obese Filipinos. This is the study of Dr. Romero, Marisa Romero, and her colleagues at PhilRice. Okay, and brown rice contains tocos and other phenolics, and that added to its beneficial effect. We have also malunggay. Dr. Completo, I think, doing work on malunggay. So the specific components of moringa preparations that have been reported to have hypotensive, anti-cancer, and antibacterial activity. So all these components contribute to the beneficial effects of consuming malunggay. So while for us who are visiting in the Philippines now, I hope that you will get the chance to eat more moringa. Okay, so in order to advance functional food research, we also need to have advanced tools available.
Oh, we apologize for the technical glitch. I suppose the recording of this will be made available via the PAASE website. So we'll just continue with the program, right? Thank you very much, Dr. Myra Villarreal. I remember, eating one of the Japanese delicacies that she described, the natto, and I did not like it because it's so sticky and slimy, but it's very, very nutritious. Ayaw niya. Okay, now we are pleased to introduce our final plenary session speaker for this afternoon. And the topic is multi-sectoral approach to disease outbreak preparedness in the Philippines, integrating surveillance, diagnostics, and vaccine research initiatives towards an effective response. Leading this discussion is Dr. Homer Pantua. Dr. Pantua is a veterinarian and scientist who has led both antiviral and antibacterial drug discovery efforts. Currently the CEO of Bioassets Corporation and Senior Principal Scientific Researcher at Genentech. He is a pioneer in the development of therapeutics from recombinant DNA technology. Please welcome Dr. Homer Pantua.
Maraming salamat po. Thank you to the organizer of APAMS, 44th APAMS, especially to the Dr. Gladys Completo. Greetings to USEC Buendia and Executive Director, Picard Executive Director, Dr. Reynaldo Ebora. So, oops. Tulad ho ni Vic, ako po ay tubong taga Los Baños. I am 5-10 minutes walk galing dito. It's very nice to be here. I remember this place. I took all my PEs here. I think I failed one. So, but it's very nice to be here in my alma mater campus. So, but today I'll be talking about the work of many people and agencies and institutions that we collaborate, integrating their works on surveillance, diagnostics, and vaccine research towards an effective response to disease outbreak. So, but before I continue to the technical, I would like to introduce to you our group. So we are Bioassets. We call ourselves Bioassets. The best assets of our company is our people. And we started as a contract research organization, but we dream to be a life science company here in the Philippines doing veterinary biotechnology. And our primary goal is to contribute to the advancement of food security and general welfare of our country. So bioassets was conceptualized and founded by entrepreneur, veterinarians, farmer, and scientists myself with a basic foundation of serving the people. So what do we do at Bioassets? So as I told you, we are a contract research organization. We were founded 10 years ago. It's our 10th year this year. So we do a lot of diagnostics for the animal industry. We do a lot of gene expression for clinical trial execution, management and execution and management. We established the point of need diagnostic here in the Philippines. We are also venturing into customized vaccine, which I will discuss a little bit later. We are also venturing into lab animal medicine. We are actually doing right now biologicals for food and therapeutics, even in companion animals. So pinapasok na rin po namin yan. And when I came home 2 years ago, one of the things that we have problems with is importing reagents here in the Philippines. And I am very happy to tell you that we are actually putting together a research reagent production here in UPLB. So the focus of our company is infectious diseases. And we know that infectious diseases have devastating social and economic impact. It ranges from healthcare, deaths, productivity, livelihood, travel, trade, and most especially food security. So the research activities that we have right now, we work on bat viruses, avian influenza, salmonella, which affects both human and animals. But one of the focuses, the main focus of our company right now is we're working on mycoplasma, a major problem in swine, porcine respiratory syncytial virus, and African swine fever virus. And for the first part of the talk, I'll be focusing on the African swine fever virus. So bear with me, there will be some virology involved. So just to give you an overview, African swine fever is a highly contagious and highly fatal disease of pigs. It doesn't affect humans. It only affects wild and domestic pigs. And these are the clinical signs of African swine fever. It ranges from fever, loss of appetite, lack of energy, hemorrhages, and some pigs and sudden death, but some pigs still survive. And the status of ASF right now is that in the early 1900s, it started in Africa, and then it moved to the Europe, and then now from 2018, it spread to Asia and now to the Philippines. So what causes African swine fever virus? African swine fever is caused by a DNA virus. It's the only member of the Aspergillosis group of viruses. It's a very large envelope virus. It's very complex, as you can see here. It expresses 54 structural proteins. It's a very, very big virus. So that's why it's very hard to make a vaccine for it. Here are the major components, which are targets for vaccines and diagnostics. And there are 24 genotypes so far. That's why it's very hard to contain. But so far, the circulating ones is the genotype 2. So there are the virus belonging to one P72 genotype may be serotypically heterogeneous. That's why the vaccines should match whatever is circulating in the locality. So just a short overview of the Philippine swine industry. It's the largest among the animal industry. It's approximately 200 billion industry. It's second largest contributor in agriculture next to rice. In the Philippines, before 2019, 60 to 70% of the swine production is contributed by the backyard operation, but not anymore right now because they were obliterated. So imagine the many livelihoods that have been lost due to ASF. So how did ASF progress in the Philippines? It was first detected in July 19 in the province of Rizal. It was suspected to be coming from local farms who actually use food scraps or swill from hotels that have been suspected to be importing meats from other countries. So this is how this is what happened right now. Of the 82 provinces of the Philippines, 73 provinces has ASF right now. So from 2019 to 2021, you can see a negative 20%, 26% growth in swine production. That's a very, very big loss. In 2019, we have 1.6 million sows, which equates to 16 million pigs at any given time. We were one of the top 10 producers of pork in the world. And we are in the top 5 pork eaters in the world. So that's why pork is very important in our culture. So, but now, as you can see here from the bulletin of the Bureau of Animal Industry, ASF is still a problem. You can also see in the World Organization for Animal Health below, it's still a problem globally. And here in the Philippines, it still poses a serious threat to our industry, and which means it's a national concern. And it's happening because there are several unmet needs that haven't been fully met. For example, our lack of ability to rapidly respond to outbreak at the point of need. Next is the lack of safe and effective vaccines. ASF does not have an approved vaccines yet. And inaccessible molecular characterization of pathogens. Admittedly, we have a very, very good genome center, but the focus is not animal health. So we need to focus also because the agriculture contributes to our country. So admittedly, in the Philippines, the approach to the animal health, especially diagnosis, is very reactive. So we only diagnostics when we see clinical signs. And when we see clinical signs, it's basically just damage control, which equates to cost. So what we advocate with bioassets is that we should do proactive diagnostics, which means that we routinely test animals, both animals and the environment. And what happens is that, and we should not be stopping at the negative, positive for the PCR, but we should characterize our pathogens. And when we do this, the diagnostics will give meaning information, and that the value of the diagnostics will offset the cost of diagnostics. And the information will support sound decision making. And when this happens, we'll be able to establish preventive measures which will equate to insurance. So to address these gaps in the animal industry, what we did is we established the Bridges Project, which is the brisk response through in-location diagnostics and genome sequencing. And the idea is to establish a comprehensive and unified approach to address the threat from infectious diseases in the animal health industry. And this project, the objective of this project are anchored in three focus areas. One is the point of need diagnostics, where we built the very first mobile biocontainment laboratory. Next is the precision diagnostics, where we do not stop with the yes or no. We pursue molecular characterization of the pathogens to support the third one, which is precision medicine or precision vaccinology. And this project is supported by the Department of Science and Technology through the BIST, or Business Innovation for Science and Technology, under the Science for Change program. So as I've told you, we built the very first mobile biocontainment laboratory. It's not an ordinary laboratory. It's a biocontainment laboratory where we can actually support rapid response, continuity of operation in the resource-limited areas. It supports decision-making on-site, capacity building in the provinces, in the regions. It can also support research and surveillance while maintaining biosafety. This is very important because you cannot do just testing anywhere. We have to comply with biosafety measures to protect ourselves, and biosecurity measures to make sure that the pathogens are actually contained and secure. So we are very proud because this is Gawang Pinoy. From the conceptualization to the engineering, it was peer-reviewed by a global biosafety engineer. And I just want to give you a short, and the key features, it's a 3-partition laboratory. It has an anti-room, analytical room, biocontainment room. It is supported with a lab information management system, and it's inspected and peer reviewed by the WHO and global biosafety engineer. So we got a thumbs up that ikwento ko sa inyo nung makita ito nung engineer, he inspect all of the BSL-3 in the world. So when he saw this, you Filipinos are very crafty. Yan ang sabi nila sa atin. Kasi a lot of mobile laboratories are big containers, but it won't work in the Philippines, especially in animal industry. It needs to be a compact laboratory that you can take to the resource limited area. Yeah, so it's not only supported by the Department of Science and Technology. Last year and early this year, this project was awarded the United States Health Security Partners Challenge Grant to develop standard operating procedures and virus assessment. So we even had the workshop and convene all the stakeholders and users to put together a working standard operating procedures. So this just shows the rapid response mobile biocontainment laboratory proof of concept. This is in Bataan. And what we want to show here is that we can do receipt, sample on-site testing, analysis, and the release of results in a timely and high throughput manner. So we can do 150 to 250 samples on site, and we can tell the veterinarian and the farmers, do not move the animals because it will to support them and establish prevention and control measures. So what are the challenges of doing this? We cannot use one for the whole Philippines because we have 7,641 islands, and approximately 60% of the swine production are from backyard operation. Now they're coming out again. And not all islands and regions have access to diagnostics. So what we're doing right now is we're collaborating with local government units as our cooperating agency and implementing agencies. We are trying to capacitate the regional animal diagnostic laboratories and local government units, but it's not enough. So what we're doing right now is we're deploying and we're collaborating with state universities and colleges for them to be the center for research and innovation using this platform. And in 2022, we were able to deploy the very first prototype of the rapid response mobile laboratory in Central Mindanao University. And now we are currently putting together the one for UPLB, for the College of Veterinary Medicine. So what if we have all those samples? These samples needs to be processed. We need to get more information. So it has to be a holistic approach. As I've told you before, we need to put a comprehensive approach, on-site testing, molecular characterization, and the applications such as diagnostics and vaccine research. So what we've done right now, we have a graduate student in bioassets. We have 3. This is the very first. Andy Montesilio is the very first graduate student in our company through Picard Great Scholarship. Thank you very much. And what he has done is that he was able to establish the genomic approach to tackling ASF. He was the first person who locally sequenced and assembled African swine fever virus genome. It's very simple. It's not a high-tech technology anymore, sequencing. But the work that he had done, the information that he had contributed to the industry is very important because it supports diagnostics and vaccine research for the swine industry. So this is published already. So he didn't stop with this. So what he did is we did a small epidemiological study from samples from Pangasinan, Cagayan de Oro, Bacolod, Mindoro, Batangas, Bataan. And what he saw is that they are all genotype 2, but and they are the genomes are most similar to the ASF Timor-Leste strain. That's good. It's still the genotype 2 that China has and other country has. But what's important in his finding is that some of the circulating strains already are showing some evidence of mutations, and not just small mutations. I cannot show this to you here, but these are duplications, deletions, and amplification and duplications that he has solved, which is very important for us. But what's more important is he has established the system already where we can do a plug and play sequencing, processing, and analysis. And just to give you an idea, Andy Montesilio can do this, and our team can do this in 3 to 4 days. And in 2022, 2021, Philippines does not have any information, no submission. Now we have 11 and we are counting, and not just ASF and many more other viruses. And what's important with what Andy did is that he generated information for evidence-based policymaking, and I'll walk you through this. So this is just a closer look of the genome of the African swine fever virus that we sequenced. I'd like to drive your attention in the orange pin, which is Mindoro and Bacolod. So Bacolod had ASF first, and Bacolod and Mindoro has trade activities. And they were thinking, how come Mindoro, where did the outbreak in Mindoro come from? And the only evidence that they can say is that they have trade activities. So what Andy did is he did an analysis wherein he saw that Mindoro and Bacolod clustered together, which suggests that these two viruses, the infection in Mindoro most probably came from Bacolod, apart from the information that they have trade activities. So now we have an evidence-based or science-based support that we can confirm that this is actually coming from Bacolod. And this is very important in policy making. So how do we use this information? Now we know the ASF molecular characterization. Can we use that in diagnostics? Can we use that in vaccine research? So today I'll be talking about vaccine research briefly. So in ASF, for an ASF vaccine to work, it needs to induce both T cell and B cell response, both in a very, very fine-tuned manner. And there are many platforms or approaches to developing ASF vaccine. One is inactivation approach. But it's the most safe, it's the safest approach, but it hasn't been shown to be effective. So if you are following the news for ASF vaccine development globally, there are live attenuated vaccines. Two of these have come into the Philippines. These have been shown to be effective in a small scale. However, there are still safety concerns with live attenuated virus. It's because that these live attenuated viruses can revert to its virulence, which it could be a temporary solution, but we don't want it to be a permanent disaster. That's why we need information. Kailangan pag-aralan natin to ng mabuti. So we will know that this vaccine is safe for use in the swine industry. So another approach is the subunit approach, which could either be DNA, recombinant subunits such as proteins, or recombinant viral vectors, which expresses the proteins. So this platform or approach is the safest. This is a very safe approach. However, we haven't seen a long-lived protection for the animals. So the question is, can we actually combine the strengths of the live attenuated virus and the subunit virus? And I believe, and I hope, also big believes, that we can do it in the Philippines. So we establish a group, we create a group where we can actually tackle and do ASF vaccine research here in the Philippines. So we're doing a development of a vector-based African swine fever virus vaccine using a nanoparticle, a well-characterized nanoparticle, which was developed in UC Davis. But we will be introducing another approach where we can actually put DNA that will express subunits. So now we have the power of the virus, the intact virus, and the strength of the DNA that will induce T cell response. So here, so it's a well-characterized hepatitis E virus nanoparticle. It's a well-characterized and it's modifiable. We can actually display both B and T cell epitopes through a display or a DNA. And you can use and from then we can generate a subunit ASF virus, that nanoparticle that is bearing the DNA and the virus and the proteins of the African swine fever virus. So where are we now? So in terms of precision diagnostics, we started with ASF because it was a national concern. When we talk with the Department of Science and Technology, let's address ASF. 2 years ago, when I came back here in the Philippines, we were working on ASF. It was very hard, but it was very exciting, because 2 years ago it was just this, and now it grew to this. Now we are working on infectious bronchitis. Our group has generated the very first lineage analysis of infectious bronchitis here in the Philippines. Our group, we've been having problem with porcine respiratory and reproductive syndrome virus here in the Philippines since the 1980s. It's a big problem in the swine industry. Our group here has generated the very first lineage analysis and recombination analysis of this virus here in the Philippines. Avian influenza, our paper had been submitted. Hopefully it gets approved, it gets accepted. We are also going into the companion animal space. We're working on canine parvovirus right now and canine distemper virus. We're also working on bacteria such as Avibacterium paragallinarum, which affects our poultry industry, particularly the egg-producing segments. We're working on Salmonella, a very big collaboration with UP Diliman, Mycoplasma, bacteriophage, and Haemophilus, a lot of bacteria. So it's very exciting times. We're open to collaboration, and we hope to grow this work. And the idea is to use this information for precision vaccinology through customized vaccine. So what is customized vaccine? Customized vaccine is basically taking the pathogen, the microbe from the farm, and use that as our vaccine in an inactivated form. So what we've done right now is we have generated a very comprehensive biobank of pathogens of poultry and the swine. And we've done comprehensive diagnostics, comprehensive molecular characterization, and all of those are well annotated in a biobank. In times of emergency, we'll be able to produce the vaccine as an isolates or through recombinant DNA technology. So right now, in our R&D, we are working on 2 bacteria, one in poultry and one in swine, and a virus in both segments. And this is led by our very talented researchers and veterinarians in our group. And so what's the big picture of what we're doing? What we're doing is for the past 2 years, we're generating information. We cannot do vaccine research without the information. So we've done a lot of discovery, detection, evolution, diversity, for us to be able to support the application process. So I follow this because I came from Genentech. We do a lot of drug discovery. Before we do drug discovery, we need to generate information. And now we are working on diagnostics, drug targets, vaccine research in small scales. And we are also working with the animal industry and our government to give information in early warning system. And with the hope that the outcome of this will be protection, prevention, mitigation, and productivity. So in the last few slides, I'd like to give you an overview of the other multi-sectoral approach that we do, like bat viruses, avian influenza, and salmonella. These are very important pathogens that we need to focus on also in the Philippines. So salmonellosis is it's a problem in livestock and in the human health. It's a public health concern. So what we're doing right now is we created a group. It's a salmonella surveillance in the egg production chain. It's also supported by Bioassets Corporation and UP Diliman. So it's basically led by another great scholar. Thank you very much again, po, from Picard. And what we're doing, it's a collaboration with Dr. Windel Rivera. And what we're doing is we're doing a surveillance, a detection in every points of production in the egg production chain. And the idea is for us to be able to detect and trace where the problem is, for us to be able to put together a prevention and control framework that starts with detection, treatment, identification, tracking, elimination, and then again surveillance. It's going to be in a loop. So it's happening right now. We collaborated with one of the biggest egg cooperatives in Batangas, also a BIST grantee of ours. So that's why when I titled this, it's a multi-sectoral approach of academia, industry, and government. And then another is pandemics. So many infectious diseases leading to pandemic, many infectious diseases leading to pandemic has been caused by zoonotic pathogens that are transmitted to humans due to contact with animals through either breeding, hunting, and global trade. So at the center of this is bats. So what we're doing right now is, what we're doing is we put together a group of highly talented wildlife biologists, microbiologists, virologists, drug discovery scientists, molecular biologists, and genomics people to address the pandemic preparedness. And we put together PREVENT project, which is the pandemic response for preparedness for emerging batworm viruses from rural and peri-urban environments. And this is approved by DOST already. And hopefully it should be executed in the next, late this year or early next year. So our hope is to do a surveillance at the interface of human and bats. And the idea is to do a lot of genomic study of all the viruses that we can actually get from these samples. So what's the importance of that? So the importance of that is that what we're gonna do in the next phase, as you can see here on the third circle, is that we are going to do a host tropism and host susceptibility assay. What we want to know whether these viruses can actually infect many different species of animals, including primates, non-human primates, and human cell in a cell culture platform. And also we're going to do biobanking studies. And with that, we'll also put together a vaccine platform, a toolbox vaccine platform, which we hope we don't need to use in the future. So, but if we need to, our hope is that we have the information already that we can use when it happens. Oops. And lastly, as you have heard in the news of avian influenza, particularly the highly pathogenic avian influenza, it affected humans in Cambodia. People have died from it. In the United States, they have reported it in cows. So here in the Philippines, it's present also, particularly the H5, HPAIV. And what are we doing here in the Philippines? What we're doing right now is we're going to prepare before it happens. And what we're doing is we put together a project ready. Mahilig po kami sa acronym, no? It's a rational vaccine design informed by epidemiology of avian influenza viruses in domestic and wild bird communities. It's under review. It's the group team is composed of microbiologists, virologists. Dr. Christina Layson is a fellow ballistic scientist, wildlife biologist, and a group of highly competent microbiologists and molecular biologists. So what do we hope to do? What we hope to do is that we would like, again, to generate information in domestic poultry and wild bird communities. Has been highly accepted that the wild birds actually transmits avian influenza, specifically the highly pathogenic ones, to the domestic poultry. And what we're going to do is to generate information, collect samples, generate information, molecular characterization of HPAI, and then use this information to establish the reverse genetics here in the Philippines and put together a platform that will make a completely matched avian influenza virus with the circulating strains here in the Philippines. Yeah. So even before the approval of the, hopefully, even before the project happens, we've been doing activities with bioassets already and UP Los Baños and UP Diliman. So we've done sampling and bioinformatics workshop. We've done a lot of several activities that will increase the competence of everyone in the team. And we are proud to say that we have generated the very first whole genome sequence of avian influenza, highly pathogenic avian influenza virus here in the Philippines, with the leadership of our research director and another fellow Balik scientist. This is submitted to pathogens already. And hopefully we can continue this surveillance so we can help the poultry industry and hopefully protect our general public. So what we have been doing here at Bioassets right now? So at Bioassets, we believe in collaboration. We collaborate to create. We believe in the academia, industry, government collaboration. And we cannot do all of this without this multi-sectoral approach. As you can see, there are SUCs already, DOSTs here, DA, even foreign collaborators, but we want to grow this collaboration. That's why hopefully before the end of this meeting, we can actually talk and collaborate with each other. So at Bioassets, what we believe is that we should put together an atmosphere that encourages collaboration, an atmosphere that fosters innovation. But not just that, because we believe that we don't have the best ideas always. But what we're doing at Bioassets is we're creating an environment where great things can happen. And not only that, we're also creating a physical environment where great science can happen. And I hope, and I'm very excited, our very first own building will be built here in UP Los Baños. And with that, we don't only do, tapos na po ito. We're also committed in training our young generation, the next generations of scientists and veterinarians. That's why we put together the Bioassets Academy, where it's a venue for knowledge transfer, skills development, and professional empowerment. So far, we've trained over 100 of interns already and professionals for them to be industry ready. So with that, I'd like to thank DOST, Picard, PCHRD, ITDI. And of course, I don't want to leave this stage without thanking our collaborators. and Balik Scientist Program for taking care of me for the past 2 years. Actually, my terms of engagement was 2011 and then 2020. But it ended already. But I think I'm a Balik Scientist by heart po. So maraming salamat po sa inyo, DOST. And with last with that po, I'd like to, before I end po, sorry, I'd like to end this presentation by rallying everyone to collaborate. And I hope that before the end of this conference, all of us, myself included, will leave a lasting inspiration that we can actually do great science here in the Philippines that will help build a better Philippines for you, our families, and myself. Thank you very much.
Hello. Yeah, thank you very much, Dr. Pantua, for such a comprehensive presentation of your wide-ranging and proactive, preventive efforts, to like study, understand the effects of viruses, pathogens, to prevent potential occurrences of problems in the future. So we shall now have our open forum. Please speak closer to the microphone so we can hear your voice. So we would like, in the interest of time, we would like to limit the questions to three, preferably one for each of our speakers. So we have a microphone over there. Please say your name and who do you want to address the question to. The floor is now open. Any question? Dr. Leah Croucher.
Yeah, I have a question for Homer. It seems like what you said, there are so many pigs in the Philippines, and many of them are in backyards. How do you plan to vaccinate all of these pigs? Do you have the capacity to produce all of the vaccines from your facility?
Very good question po. So in terms of vaccination po, did you mean any of the vaccines that we hope to produce?
Yes, the ones
Yeah.
that are useful, obviously, the efficacious ones.
So for example po, we have one in development. It's a bacteria. So the idea of the company, it's not a commercial vaccine. So we're working on autogenous vaccine or customized vaccine. In autogenous vaccine, it's basically small batches. What we do is we isolate the microbes or the bacteria or viruses from the farm, and we make a small batch of vaccine for them. And you're right po, it's very hard so we can do it with one farm, two farms, but we cannot do it for the whole Philippines. That's why once we prove that we can actually do the biomanufacturing here in the Philippines, our hope is to get help and assistance so we can actually scale up and serve the whole swine and poultry industry here in the Philippines.
Yeah, don't you think that the industry itself should provide, and facilitate this vaccine production, because they are the the consumers, right?
Yes po. Actually po, a lot of the stakeholders, farms, corporate farms are actually asking us and the industry, if we can actually do it, then there are stakeholders who will support the biomanufacturing here in the Philippines.
Yeah, I was wondering if you can actually put it in feeds rather than, injection.
Um, the reality is, it's okay po talaga. But the problem po in the swine industry and the poultry industry, for you to be able to administer the vaccine, for example, for pigs, you need to be for them to be able to eat all of the feeds that you give so they can take the vaccine. And that would require off feeding of the pigs or poultry several times because there are so many vaccines, and off feeding them several times will actually reduce the average daily gain and the feed conversion ratio of these animals. That's why we still do the parenteral routes po.
Thank you so much and congratulations.
Uh-huh.
Do we have other questions from the audience? Dr. Giselle Concepcion.
Okay lang po.
Oh.
So,
It's okay. Go ahead.
so good afternoon, everyone. I'm a student from Central Mindanao University, and I have again a quick question to Dr. Homer. So given the archipelagic nature of the Philippines, how can we ensure an equitable access to diagnostic services and vaccines, especially before and during the outbreak? That's it. Thank you.
Um, yes, I think that's very hard po talaga. But I think the way to do it is one of the reasons why we have problems supplying the resource limited regions of the Philippines. It's because we are always at the mercy of other countries. We are dependent on importation of all of these vaccines here that we use in the swine and poultry industry. And for us to be able to solve that, we need to do it here, at least support. For example, we can actually focus on the resource limited area, because admittedly, some of our multinationals, ang interest nila is yung commercial farms. Mas maraming there will be more profit. I know they help also, but the interest is lower in resource limited areas. That's why in our company, as I've told you, is based on the foundation of serving the people. If and when we reach that stage that we can actually make it, we will prioritize the regions, because right now we can only make very small batches, and it's only in the R&D stage. But when that time comes, I hope our government will still give us the trust and confidence to scale it up so we can serve the underserved regions of our country.
Thank you for that question, Dr. Concepcion.
No, it's not Dr. That was not Dr. Concepcion. Now I'm going to ask the question. Anyway, congratulations to our speakers, including the one, who's sent it virtually. But I'd like to ask Homer and also Vic about the subunit vaccine and how you would combine it perhaps with the autologous as a way of pandemic preparedness. So I just wanted to clarify what subunit, and that in relation to our discussions on DNA vaccines for ASF. So that surface, is that the surface glycoprotein subunit, or, just please clarify that. And the interest of the audience, we belong to the AI and ASF group or committee of the NAST, headed by Dr. Maala of VetMed. But then CM Vic, corresponding member Vic, had joined us. And even then, before Homer became a corresponding member of the NAST, which he is this year, he was already our consultant. And so we had discussions on vaccines, but even before that, Homer already said the first things we have to do would be to collect the samples of the viruses. He has the infrastructure to do this. And now he's collected and he has sequenced them. From the time we started our discussions now, Homer has presented whole genomes of at least 2 viruses in this talk. So congratulations and kindly clarify my questions. Thank you.
Oh, thank you very much for the question, Dr. Giselle Concepcion. So the proposal that we have with the OST, it's actually led by the Industrial Development Technology Institute of the OST. It's a nanoparticle vaccine that will be displaying epitopes either through recombinant DNA expression. And the targets are, I cannot tell you. But the targets are capsid, surface protein. I can tell you that the CD2V is a target. It's an attachment protein. It's the proposed attachment protein of the African swine fever virus. There are B cell epitopes. There are T cell epitopes. Right now, we're looking at six either one in a particle and then they will be combined as a concoction. The idea is to induce both B cell and T cell response. It's very important to understand that because in ASF, if I may give you a pathobiology of ASF, ASF infects macrophages. And when infects macrophages, it induces a plethora of cytokines, which stimulates or results in cytokine storm. So when you have cytokine storm, as you have known from COVID, it results into sepsis. That's why the pigs die suddenly. So there needs to be a fine balance between B and T cell epitopes, because if you induce the B cell response too much, you will be inducing antibody-dependent enhancement of infection. So it's like dengue. Oh, it's like dengue. When you have antibody, the more you're going to be infected. So there needs to be a fine balance. When you have B and T cell epitopes, you cannot induce hyperinflammation. Because if you have a lot of TNF alpha, a lot of these IL-6, IL-1 beta, a lot of these cytokines, you will destroy the barrier, the vascular endothelial barrier of the vessels of the animals, and that will result in sepsis. So it has to be a fine balance. You have probably 6 epitopes that we are considering either through display or DNA, right? So if I may add, so one of the things about this particle vaccine is it was actually by accident. So this is actually something from UC Davis, because a former colleague of mine, whom I was doing a postdoc, he was a grad student. We worked together 30 years ago. And then during VIP, we had to try to recruit him to help us with electron microscopy. And that's when I discovered that he was working on this particular particle. What's interesting about this particle is that it's derived from hepatitis E. And the plan we have for this vaccine is it could be taken orally. The reason it's important orally is because this particular ASF is transmitted through ingestion. So what you want to do is you activate your mucosal immune system. And that's important. That's why I think, again, not trying to sound anti-vax, but one of the weaknesses of the COVID vaccine was stimulating circulatory immunity, even though what you have to activate is the mucosal immunity. Then the second one, in terms of the vaccine, I think people always say, oh, you just make a protein or subunit. There's a paper 20 years ago showing that actually the antigen has to be presented. There's an interesting size. If it's less than 20 nanometers, it won't work. If it's more than 50 nanometers present, it's only T helper cells, which are. So seems to be the sweet spot is about 40 nanometers. So when you present your antigen to the antigen presenting cells, your likelihood of stimulating the T cell immunity and humoral immunity to have a stable immune response would be that size. So this particle is around that size. So that's why we're bullish about it. And with regards to the whole particle, I think as Homer was mentioning, it infects macrophages. The size of this virus is about 200 nanometers. It's huge. Then it infects the antigen presenting cells. So that already compromises you because the way to present your antigen for your immune system this virus is already attacking it. So you have to take it out of context then. So take out the antigens of interest, whether it's B cell, T cell, and then present it. So that's the rationale of this particular virus. Then I think with Leia's question earlier, so manufacturing, we're looking at the possibility of manufacturing in the Philippines. So it's actually produced by baculovirus. It's one of the cheap ways of making viruses. And the yield's pretty high for this particle. Yep. Okay, thank you.
And just to add to Vic said, because it's a 200 nanometer particle and it has a repetitive structure, it's adjuvanting already. It will induce all TLRs and everything. So we don't need adjuvants anymore.
So thank you very much to our esteemed speakers. The quality of our body scientists, actually represent the work also of USEC Leia. And we would like to request everyone to stand to prepare for the awarding of the plaques of appreciation. And let us call on the president of the Philippine American Academy of Science and Engineering, Dr. Gladys Cheris Completo, to lead the awarding. So the first plaque will be awarded to Undersecretary Leia Buendia of the Department of Science and Technology. This certificate of appreciation is awarded to Dr. Leia Buendia for her invaluable contribution as plenary session speaker during the 2024 annual PAASE meeting and symposium with the theme Filipino Scientists Across Borders towards developing regional S&T innovation ecosystem and sub-theme technological innovations towards health, food, and nutrition security, held on July 15 to 17, 2024 at the University of the Philippines, Los Baños, Laguna. The next awardee is Dr. Leo De Vico Ilag with a similar citation. Thank you, Dr. Ilag, and presenting is PAASE President, Dr. Gladys Completo. And last but not the least, we would like to call on Dr. Homer Pantua to receive his plaque of appreciation from Dr. Gladys Completo. Please join Dr. Ilag, Dr. Buendia to join all the speakers for a photo op. Maraming salamat po, and we'll now move on to the next session. Thank you.
Thank you to all of our plenary speakers and our moderator for their enlightening lectures and stimulating discussion. Now we shall be on a working break as we proceed to our panel discussion, to be followed by the awarding ceremonies. At this juncture, let us now begin our panel discussion on BSP roles in the Filipino science community and future directions. Let me introduce our panelists. First, let us call once again Dr. Leah Buendia, Undersecretary for Research and Development of the Department of Science and Technology. A round of applause for Dr. Buendia. Also with us is Dr. Reynaldo Ebora, Executive Director of the DOST Philippine Council for Agriculture, Aquatic and Natural Resources Research and Development, or PICARD. A round of applause. We also have Dr. Gisela Concepcion, Professor Emeritus of the Marine Science Institute of UP Diliman and member of the National Innovation Council. Let's give her a warm round of applause. Our panel discussion will be moderated by Dr. Just Santos, a distinguished member of the Board of Directors of the Philippine American Academy of Science and Engineering, or PAASE. Let us give a warm welcome to Dr. Santiago.
Hello, mic test. Good afternoon, everyone. I hope everyone's still awake and still energized. And also good morning to participants from the United States. We are very fortunate this afternoon to have a panel comprised of our colleagues here with me on the stage. To my left, Undersecretary Leah Buendia, Dr. Reynaldo Ebora, and Dr. Giselle Concepcion. As we all know, they have direct and important policy-making roles associated with science and technology, or more accurately, the larger STEAM fields. I'd like to introduce myself. I'll be very quick, I promise. I'm Just Santos. I've been lucky to have served as a balik scientist twice prior to it becoming an official Republic Act, as well as a Fulbright Scholar. My balik scientist collaboration with De La Salle University more than 10 years ago to date have generated at least 30 journal publications, various book chapters, and a book that you can purchase at Amazon.com. Nag-plug pa eh. So these topics are centered on disaster risk management. But this event is not about myself. Prior to this event, we have collected a myriad of questions from the participants, spearheaded by Dr. President Gladys Completo, and I, as a moderator, merged and prioritized them into a fewer set of questions. And I didn't tell them because I don't want it to appear scripted. So I've already allocated the questions to each of my panelists here. I tried to equitably balance the questions, but please feel free to make an add-on response to all the questions that I'm asking. So time permitting, we're already delayed by about 15 minutes. We could open the floor for audience questions. After I'm done with the 7 questions that I prepared, 2 questions for each panelist and 1 last questions that all the 3 panelists can answer. With no further ado, let me now begin with the first question for you, Leah. I really enjoyed your presentation earlier. You gave examples of success stories in your presentation. Can you provide further insights into the metrics that are used to measure the success and impact of the Balik Scientist program?
Thank you very much for the question. I think there are other matrices, like for example, number of students that have been mentored, and even way after the Balik scientists have gone, there are other matrices like have these young researchers already can submit their own proposals to the different funding agencies, or have they even started doing their own researches? That's another metrics. Another metrics of success, I think, is that if these Balik scientists have touched also the industry partnership that have been there for quite some time and have not been awakened by the host institution. And another matrices, actually we can name a lot of matrices for the success, but even after those Balik scientists who have been engaged twice or three times, have they decided to come back for good and actually help the Philippines develop the science, technology, innovation ecosystem?
I'm very sure that your presentation just showcased the tip of the iceberg. Throughout the PAASE, we have witnessed successful stories, presenters, and those balik scientists themselves who are here physically in this venue. So the second question is for Dr. Ebora. What strategies are being implemented to attract Filipino scientists and experts from abroad to participate in the program? And how do you address the challenges of convincing highly skilled scientists to return or to engage in the Philippines?
Basically, there are a lot of programs being implemented by the department to attract balik scientists. One is the information campaign and the sharing of the experiences of the previous balik scientists. They will be encouraged to avail of the program. The other thing is the recognition given to the balik scientists for the outstanding contribution that they have given to the country and the development in the scientific community. With respect to the different programs, na ngayong second question mo?
To attract highly skilled talent from abroad to participate.
Yeah, basically, but that the other program is actually to give more incentive to the balik scientists and be able to access the grant, the research grant. For example, in the case of Picard, several students were mentioned under the GRADE program. Picard has recently launched the I-GRADE, which is the International Graduate Research Education Assistantship for Technology Program, which is basically a special program wherein the scholarship money is provided by SEI, and Picard is the one providing the research money. But they have to work on a project funded by Picard. So in that case, once they have developed the technology and the partnership, they will be able to continue the relationship. And at the same time, we are encouraging the balik scientists to host our students in their laboratory. So one example of which is Dr. Benildo de los Reyes, who has recently been assigned one graduate student to work on his lab, and that is under the I-GRADE program of Picard.
Thank you very much for your very insightful answer, Dr. Ebora. So we'll now move on to Dr. Giselle. As someone who has proactively provided policy feedback and potentially you have hosted Balik Scientists and even beyond the Balik Scientist program, what kind of support system is in place for Balik Scientists to ensure their successful integration and productivity in the local research environment? Just yesterday, we were talking about the impact of our research and how it will trickle through local government units.
First, I'd like to really commend the DOST Balik Scientist program. And I'd like to point out the VIP program as a model, because I think that for Balik scientists to work effectively here, they must have a concrete or specific project to work on. Secondly, they must know that they will be working with fellow scientists who are of the same high caliber. So in the case of VIP, you recruited not just one or two, you recruited Vic Ilag, Homer Pantua, Christina Layson, who among themselves knew that together they could make an impact. So I would say that for every major program of the DOST area of development, you could also consider maybe coming up with a team of foreign-based scientists who you think might work well together and be incentivized to come home for good. Now, that's not always an easy task to identify the people. In PASE, we more or less know the people who might be able to help you. and their age groups or their generations. There are some of us who are already retired and already well established, say in the foreign country, and therefore would not be attracted to come home for good. But it does not mean that they cannot be major advisors or consultants, especially with online meetings. But then you have this breed of middle age to young members who might still be enticed to come home for good. Not only that, now PASE is directly linked with the young researchers called Pinoy researchers all over the world, led by Reina Bel Reyes, who is based at the NIP. And she's in touch with young PhDs who are in industry or in academe abroad, and they're the ones who could be incentivized to come home for good. There is actually also a grad map training program that is being implemented by this group of young scientists and engineers, and PAS has also contributed to that. But on the other hand, if the incentives are not right, then it would be hard to entice our middle to young aged scientists in the Philippines, because they'd have to think of their welfare and their family's welfare, and they have to think of what they would have to give up in terms of, the quality of life. I know it's important for us to maintain our loyalty to our country of birth, and that makes us our, personalized heroes for the country. But on the other hand, we have to be realistic about why people have left the country and have not yet come back. So the incentives here would be good. In UP, we implemented the Balik PhD, faculty PhD program, and we had this is for the long-term Balik Scientist program, which is really our goal. So we had an outright relocation package of 500,000 pesos. And that is because UP will not provide the housing. So where would they live? So they would use that money to pay for their apartment rental, for example. And then based on an approved proposal, research proposal, we gave a startup grant of 2.5 million pesos, renewable. Now, what's great about the DOST program is it's not just to the universities that you are allowing our Balik PhDs to come home to. You are also enticing them to the government agencies and also to the private sector. So those are just some of the things that I thought I would share with you.
Thank you very much, Dr. Giselle. So the next question is for you, Secleya, again. I think this is a hard question, but you can answer this very confidently. What are the current challenges faced by the Balik Scientist program? And how can government policies and institutional support be improved to better facilitate the goals of the Balik Scientist program?
Well, in any program, there are always challenges, meaning it's a live program. That's why you always encounter challenges. For the Balik Scientist, one of the major challenges is how to link the scientists to the host institution, because most of the host institutions are not familiar with the Balik Scientists. That is why we are rigidly and aggressively promoting our Balik Scientist program so that we go face to face with the Balik Scientists, encourage them to come back and match them with our host institution. That is one major challenge, to link our Balik Scientists with the host institution. And second, I think another challenge is the host institution should know very well what they can get out of the engagement with the Balik Scientists, and make full use of the engagement of the Balik Scientists. Since government is funding, we make sure that the host institution will benefit and make the maximum benefit out of the engagement. for policies, I think we must increase the budget for the balik scientists in order for us to have more balik scientists come back and come back for good. Particularly for scientists who have decided to come back for good and serve on a long-term basis. There should be one host institution who will give a regular position to the balik scientists, and this is on a salary grade 24. But for me, I think the salary grade 24 is not as competitive as it should be. And therefore, I think the policy should at least have a salary grade 29 or 30 for a balik scientist to stay for good.
Thank you so much for the beautiful answer, Yusek. So the next question, actually, I just learned it literally today from Yusek Lea's presentation, but I'd like the question to be addressed to Dr. Ebora. So in your beautiful map with the data, it shows that there's a much heavier concentration of interactions in the NCR region. And you, Dr. Ebora, as the Executive Director of PICARD, how can we make it more equitably balanced across the Philippines? How can local universities and research institutions better collaborate with balik scientists to maximize the program's benefits, not just to the NCR, but equitably throughout across the nation?
Yeah, basically, we have to provide support to SUCs and research institutions in the regions. Because in some cases, they have some difficulty in hosting because they don't have existing program. So what we usually do is we fund research project, give them research project, and if the performance is good, we encourage them to avail of the Balik Scientist program as hosts. But at the same time, provide some support in terms of the capacity building through the IDD grant, the Institution Development Grant. Because sometimes the Balik scientists have the idea, but they don't have the facility to implement the program. And you need some time to prepare the institution to be the host institution. So at present in PICARD, we have several programs and in terms of institution development by providing equipment and improvement of the laboratory so that when the Balik scientists come to the lab, they are ready to implement their experiments. The other one is we usually dovetail into the scholarship program. So we have students that are working in certain laboratories in the universities in the region, and at the same time encourage them to look for balik scientists that can provide further guidance. So in that case, they will be working in an existing project, and at the same time, you will be able to tap the expertise of the local advisor and the balik scientists. The other program is in terms of providing small grants actually to the students through the advisor, the local advisor, and provide some mechanism for them to communicate with the balik scientists. So in that case, you will have some preparatory period, probably about 1 or 2 years, they are ready to host. And they have identified a specific project where they can work together.
Thank you so much for that wonderful answer. So for Dr. Giselle, everyone knows your name. You wear many hats. You're a professor, you're a researcher. You're 1 degree or perhaps less than 1 degree of separation with policymakers. So the question is, what do you think would be the role to boost the international collaborations, universities, government agencies, and private partnerships? How can we further boost particularly the international collaborations to improve and enhance the future directions of the Balik Scientist program?
So at present, I'm active in the National Research Council of the Philippines, and USEC Lea knows that I'm the chair of the Committee on Networking Linkages, and soon outreach will be separated already. Okay, from anyway, so I sit in the International Science Council, RFP for Asia and the Pacific, so representing the NRCP. And at present, Well, we are linking up with the Australian Academy of Sciences because the president is the chair of this committee. And it so happens, Yusek Leah, that this president, a very distinguished scientist, is in the same field of research as Dr. Gobet Advincula. So it's in nanomaterials, polymers, and additive manufacturing. So this is just one example of what we can do to increase the public image of the DOST. And we are proposing that perhaps the AMSEN facility that was established with guidance from Dr. Gobet can be used for training of our key engineers and scientists in the different SUCs and HEIs, and include the ASEAN as well, because there are only two such facilities in the ASEAN, the other being in Singapore. And I would like to take care of the other countries in the ASEAN that are on the low income level still. On the other hand, we have a linkage, for example, with the National Academy of National Research Council of Thailand through USEC Leah that we would like to strengthen and really, you might say, make a reality in terms of projects. But on another scale, I think for those in the United States, it's really the DOSC that has led in the bilateral agreements for S&T between our countries. And the PASE, to the extent that we can, should support the programs that they are, establishing. There is one recent news on the U.S. Nuclear education and training program being open now to the Philippines. So in UP, we are actually trying to get the nuclear education program established with help from our champions or partners in Congress as well. So those are just two examples. There are many more of how we can, really concretize our linkages with international communities.
I'm smiling from ear to ear right now because I'm more and more convinced that Balik Scientist program is a very successful program. So my final question addressed to all three of you. What would be your top 3, or it can be top 2 or top 4, it's up to you, advice to scholars or potential applicants of Balik Scientists? How can they make their application successful? And more importantly, how can they return here and serve in the Philippines successfully? Starting with Yusek Leah up until Giselle.
Thank you. I think it should be a partnership between the host institution and the Balik scientist. If they already have initial talks with the host institution, it's just a matter of applying, and it's just a matter of checking if they are eligible to apply or not. And the second, I think, is the host institution should be able to reach out to as many scientists as they can, because there's no limit for a host institution to host a Balik scientist. There's no limit also in age of the Balik scientist. Even if you're young, even if you're not so young, you can apply as a Balik scientist. I think the oldest that we had is about 84 years old. And there's no limit in the number of engagements that a Balik scientist can do. That is why I think the name is very appropriate, because they can balik and balik and balik. No limit in the number of engagements. So it's just that I would also like to emphasize that it's not even in the incentives, but we touch the hearts of the Filipinos to help out the Filipinos. That's why the motto, the tagline is Balik Puso, Balik Pilipinas, Balik Scientists. Thank you.
Actually, I'm going to mention almost the same thing as Euclea, so I'll just do it scientifically. Buendia 2024. But basically, I think one of the important things is to look at the terms of reference so that it will be clear what will be the type of engagement that you are going to take and discuss it properly with the host institutions. And the host institution should be able to communicate it to the monitoring agency, for example, the council, so that appropriate support can be provided. Because in some cases, the Balik scientist is ready to do their actual work, but it so happened that the host institution is not ready simply because they don't have the resources. So if it could be planned ahead of time, then the council can actually provide the resources in terms of a project or probably additional support to the institution so that when the Balik scientist comes, then the lab is ready to host the Balik scientist. The other thing is he or she should be ready to exercise some flexibility. Kasi medyo iba ho yung situation kasi natin dito. For example, procurement is a big problem. So if you're going to plan your experiment and you're expecting that reagents will be available soon, then you have to have some maybe advanced planning because it usually takes time to acquire the reagents, which are usually readily available in your laboratory. And I think what is more important is to bear in mind that this program is actually to serve the country, which is very well appreciated by the Filipinos. And it will have a big impact to the scientific community and the Filipino community in general. So thank you po.
Giselle.
So, so I'd like to say that the PASE nominated me to be an executive member of the National Innovation Council. And well, because of that, I prepared an innovation policy paper. But one of the hallmarks of that paper is to develop the Fraunhofer model for academe, industry, government engagement. And I'd like to say that perhaps if we adopted that a little bit more in the Philippines, then perhaps many more Balik scientists would come home for good. Okay, so in that model, you would have scientists engage more closely with industry. And this is what the Secretary of the DOST emphasized yesterday. We are now working towards wealth creation. Walang masama sa yumaman from your science and technology efforts. So in that model, though, we also have to make sure that from the very start, the training and the interests of the scientists would be aligned with that of industry. And we're not just talking about big industries. We're talking about MSMEs, which would probably represent our middle class, which we would like to grow. Okay, but then I'd like to point out the other part of my policy paper, which is that we have to support the study abroad program of the DOST even more. Okay, because other countries decades ago sent their scholars abroad, the best and brightest. Then they provided a very attractive incentives for them to come home, placement in academe, industry, and government. But even so, say for the 30,000 Taiwanese that were sent to study abroad in the 60s, 70s, only 3,000 more or less came home initially, but that made a big difference in Taiwan. But other countries are also sending tens of thousands or 5,000. Now, Indonesia's sending 25,000 of their brightest scholars abroad, and the first few thousands have come home already. So this is what we are saying, that if you don't have the numbers abroad to attract back home, then you really cannot complete the numbers here. So we can count how many PhD level scientists and engineers we have in the United States, Europe, and the rest of the world. As far fewer than what there are of the Chinese, the Japanese, or even the Thai. Just think of those at the US NIH. Ang dami-daming mga ibang Asians doon compared to Filipinos. So it's really a numbers game. The next thing is the incentives. How are you going to attract them back home? And there are many ways of doing it. First of all, when you send them abroad, let it also be programmatic. It could also be a case of a group of researchers who would focus, say, on climate change or the environment. And this is nothing new because in UPLB, this was already done decades ago. And a group of UPLB professors or young faculty were sent abroad, and eventually a number of them in the group came back and created CESAM, for example, the Center for Environmental Sustainability. So, pwede rin yung programmatic, but then pwede rin, medyo academe-based, society goals-based, but it could also be industry-focused, no? I mean, strategic yung pag-support ng DOST for the Studies Abroad program, and then if it is industry-oriented, you can be sure that when they are ready to come home after their postdocs, those industries would hire them, would provide the right incentives for those scholars. Thank you.
I believe we have time for one or two questions for those who have questions or feedback to the major stakeholders here, major players here on the stage. So this is now your opportunity. I am seeing Serapika, Dr. Serapika. Please come to the mic, and if you'd like your question directed to our esteemed colleagues, please just be specific.
Thank you. I'm a Balik scientist. So clearly, I wanted to make sure that we account for all the resources that we have. Clearly, when I came back here 10 years ago, I was so lucky that there was an ongoing multilateral grant called STRIDE coming from USA, which is also to promote science and technology in the country, which we tapped into as part of the effort to increase. So clearly, I admire the efforts of USEC Leia, and of course, AD Ray has been part of our efforts in expanding the adoption, indeed, of research in the agricultural area with our PAASE members for the longest time. But what's missing to me is definitely what Giselle briefly touches, is being able to have other stakeholders come into play to be playing not only host, but support structure and also potential benefactors for our Balik scientists. And that's on one side, who can help them when they get here. In my case, USAID was there, appointments in 5 different universities, MSUIIT, PNRI. They're all with me, LaSalle, UP, because my area was tech transfer. So it was kind of easy. And it actually kept me busy for that 9 years that actually I was here. And I only involved the League of Corporate Foundations in the last 4 years and getting into STEM education. But clearly, my industry partnerships as well were the key areas that still is a work in progress. And partially our mandate now in the US and the UPTT BDO is to increase our spin-off, because partially a lot of our PhDs would need to be supported by indeed small and medium scale businesses, besides of course the consultancy that may come in from the big corporations, like in the case of Govet, working with other chemical companies. But I think we're not tapping into that available resource of the private sector in terms of being able to increase not only the impact, but also the recruitment process for our Balik scientists. Because by combining hosts, not just universities, not just government,
but including private sector, would actually increase the potential of the scientists to stay. Not much different in my own personal experience. Had it been a dull moment for me after 2, 3 years, I kept my house in Pennsylvania so I could come back. But it was never a dull moment. It's been 11 years, and I'm really looking forward for actually the other part of this is to organize the Balik scientists to create a synergy amongst them, because that's already happening in the case of Larry and Vic Ilag, as well as Homer Pantua. But we're not doing that in other areas of research that we need, because that also would catalyze the Balik scientists abroad, seeing that they have a team already working on their area and they can contribute to that team. Then it's more likely that they'll want avail of that engagement much easier. They know they're not the only one or breaking new ground, because it's not easy. I agree with procurement is the biggest problem when I talk to incoming Balik scientists as well as even seasoned scientists that come in. So by having a team already in place and creating that environment for Balik scientists to collaborate amongst themselves and to the previous Balik scientists like me, it would make their lives much easier and their utilization much better. Thank you.
Thank you, Dr. Sarafika. I think with other programs of DOST, the Balik scientists could also avail of them. An example is that of Dr. Pantua, where he availed of the BEAST program. This is a business innovation through science and technology. So it's just a matter of knowing where they are and how to avail of such incentive programs. But I agree that the private sector should play a very important role as stakeholders as well when it comes to science, technology, and innovation. And you're taking part in the technology transfer ecosystem was, I think, a crucial tipping point where the SUCs have realized that it's not all research. We should have something out of research. That is why as well, the current priority of DOST, one of which is wealth creation, meaning we have to have something out of the research work that we have done. And this is more on the application, technology transfer, and even gaining income out of all of this research results. So I fully agree. And people like you who know the ecosystem already, staying here for quite some time, can help and attract also other Balik scientists to join your advocacy here in the Philippines. Thank you.
In the case of Picard, we actually encourage the Balik scientists to work together and come up with a research proposal that can be funded either by the DOST or by the Picard GIA. So that will be a starting point. And one of the projects that we have recently approved is on marine resources, involving 3 or 4 Balik scientists. And that collaborative work involved some private sector also. So basically, you are doing it step by step. But there should be a plan wherein the private sector will be willing to provide resources. Because as of now, it's more of a collaborative research, providing facilities or providing support in terms of the technical aspect, but no actual investment yet. So hopefully it will evolve, and later on the private sector will be able to provide actual resources to the research process. Thank you.
So it's always a chicken egg process, but in our universities, we are now open to building our knowledge and innovation parks, our PEZA, KISS parks, and in UPLB, you have it. So you just have to try to get more industries to locate in the Pezaquis Park of UP Los Baños. And well, that may be an attractant for more balik scientists. Now, well, ideally in the university, in a universitas setting, the academic must have the choice to focus on teaching and mentoring, education for the next generation, but at the same time must still do the research and creative work. Otherwise, what is he going to teach to his students? That is new knowledge. But then there may be those who would like to focus more on R&D and then extension. That's like public service, but working for private good or for wealth creation with industry will redound to public good as well. So you could have a choice, and that would be attractive to balik scientists working with the existing faculty. I'd like to point out a particular area of development that our foreign-based scientists could be involved in that's critical to all of us in the computational data science and AI field, in the mathematical field. So we are already in this age where research is focused on AI. So many hundreds of thousands of publications in AI. Ideally, it would be AI that is linked with every material area of development. Okay, so in UP, we are advocating thesis, dissertations, research projects of for the environment, food, health, etc., but with a data science and AI component. And we need the experts here in UP and in other universities. I would like to end by pointing out a university that I admire. And this is a private university, and all public universities, SUCs and UP, should aim to become like this revered private university led by two of our PASA stalwarts, former PASA presidents, Alvin Colaba and Ray Montan. This is the De La Salle University, which is a research university. And we are proud to say that the Gokongwei School of Engineering has 65% PhDs among its faculty. So how are they doing it? They are providing the incentives for the balik PhDs to join De La Salle. And some of them are UP bachelor's graduates, but they know how to provide the incentives for their faculty, and not only that, for the balik scientists and therefore for their collaborators. Okay, I'm not saying that De La Salle is already making an impact on wealth creation as a university. Okay, UP and other universities will make a run for your money now that we are into the research and innovation mode as well in the university. Thank you.
Thank you very much to our esteemed panelists, and thank you everyone for your active participation. Unfortunately, I was instructed that I cannot accommodate any more questions. So our panelists will be lingering around, so probably you can just share the question with them, or we can publish it in our newsletter. To express our gratitude and appreciation for sharing with us their insights and expertise, we shall present our panelists with a plaque of appreciation. We would like to invite to the stage Dr. Gladys Cheris Completo, 2024 PAASE President, to present the plaque. Thank you. Ay, babasahin para yung certificate. Wag na.
Once again, thank you so much to Dr. Leah J. Buendia, Dr. Reynaldo V. Ibarra, and Dr. Gisela Concepcion. A big thanks to Dr. Just Santos for moderating the panel discussion. A round of applause to our experts. We will now proceed to the induction of the new members of the Philippine American Academy of Science and Engineering, or PAASE. To welcome our new members, we would like to call on Dr. Angeline Lau, a distinguished member of the PAASE Board of Directors, to facilitate the induction ceremony. Let us give a warm round of applause to Dr. Angeline Lau.
Thank you. A pleasant afternoon. So let's make this quick so that we can all go home. So it is with overwhelming joy and pride that I announce to you the newest member of the Philippine American Academy of Science and Engineering on behalf of our esteemed membership committee head, Dr. Elmer Mojica. So these individuals have been chosen for the exceptional talents and unwavering dedication to advancing the fields of science and engineering. Next slide. So this year, we are pleased to welcome 30 new associate members and 34 new full members to our organization. Next slide. So for the new associate members, Philip Alviola, University of the Philippines, Los Baños, Wildlife Biology, Bat Virology. George Hill Angeles, University of the Philippines, Los Baños, Molecular Biology, Epigenetics. Pearl Ann Ante Testard, University of California, San Francisco, Epidemiology, Biostatistics, Plant Global Health. Pamela Kahilig, University of the Philippines, Design Anthropology, Disaster and Climate Resilience. Aurelio de los Reyes V, University of the Philippines, Diliman, Mathematical Biology, Optimal Control Theory. Annalyn Españo, Eastern Visayas State University, Indigenous Folkloric Literature, Assessment and Language Teaching. Llewellyn Espiritu, De La Salle University, Microbiology, Mycology. Ivan Henderson Gue, De La Salle University, Input-Output Modeling, Circular Economy. John Rev Gilaran, Division of Social Science, University of the Philippines, Visayas, Clinical and Disaster Psychology. Mary Dorothy Jose, University of the Philippines, Manila, Women's Studies, Philippine Studies. Benedicto Militante Jr., Eastern Visayas State University, Industrial Education. Macteria Victoria Sumagang, University of the Philippines, Los Baños, Process Systems Engineering, Process Integration. Versola Sunyo, University of Asia and the Pacific, Transportation and Logistics. For those who are called, kindly stand by here behind the stage. For the new full members, Karen Connie Abalos Orendani, University of Philippines, Diliman, Social Political Philosophy, Contemporary Philosophy. Rosaline Angeles Shim, Texas Tech University, Genetics, Molecular Breeding. Jericho Bacani, University of the Philippines, Baguio, Mathematics, Analysis and Number Theory. Mary Donabel Balela, University of the Philippines, Diliman, Material Science and Engineering. Maria Cynthia Rose Bautista, member of EDCOM of the Senate Office, Sociology of Development, Sociology of Education, and Social Stratification. Michael Francis Benjamin, University of Santo Tomas, Process Systems Engineering, Risk Analysis. Francis George Cabarle, University of Philippines, Diliman, Natural Computing, Parallel Computing. Agham Cuevas, University of Philippines, Los Baños, Economics. Lawrence Anthony David, Duke University, Genomics, Nutrition, Microbiology. Benildo de los Reyes, Texas Tech University, Genetics, Plant Molecular Biology. Maria Cynthia de la Cruz, Cavite State University, Veterinary Microbiology, Food Hygiene and Safety. Dennis De Paz, Eastern Visayas State University, Statistics, Educational Program Management. Ebenezer Florano, University of Philippines, Diliman, Public Policy, Research Methods in Public Administration. Greg Foliente, University of Melbourne, Sustainable and Resilient Systems across domains and scale, including urban infrastructure and engineering systems. Victoria Herrera, Boston University, Chobanian and Avedisian School of Medicine, Molecular Medicine, Translational Medicine. Joyce Ibana, University of Philippines, Diliman, Immunology Research and Education, Food Innovations. Julius Liano Jr., Philippine Textile Research Institute, Textiles, Dye, Colorant, Materials, Chemistry, and Luminescent Materials. Jose Ernie Lope, University of the Philippines, Diliman, Partial Differential Equations and Mathematical Modeling. Andres Philip Mayol, De La Salle University, Energy Life Cycle Assessment. Ruel Nacario, University of Philippines, Los Baños, Organic and Medicinal Chemistry. Ethel Chua Joy Ong, De La Salle University, Natural Language Processing, Conversational Interfaces. Rina Opulencia, University of Philippines, Los Baños, Molecular Microbiology. Alan Abraham Padama, University of Philippines, Los Baños, First Principles Calculations, Computational Material Science. Shiri Pagsuyoy, University of Massachusetts Lowell, Contaminant Fate and Transport, Wastewater-Based Epidemiology. Marjorie Pajaron, University of Philippines, Diliman, Economics. Carl Ezra Pilario, University of Philippines, Diliman, Process Systems Engineering, Industrial Informatics, and Machine Learning. Mario Prado Jr., University of Philippines, Manila, Neurophysiology, Intraoperative Neuromonitoring. Maha Lea Rabajo, Development Academy of the Philippines, Energy Economics, Natural Disaster, Agriculture and Development Resources, and the Environment. Mark Christian Felipe Redillas, De La Salle University, Plant Physiology, Crop Biotechnology. Segundo Joaquin Romero, Ateneo de Manila University, Philippine Government and Politics, Political Parties. Francis Gregory Samonte, Boston University, Nutrition, Epidemiology, Health, Social Sciences. Jane Luis San Juan, De La Salle University, Industrial Management Engineering, Optimization Modeling. Teresa Tadem, University of Philippines, Diliman, Philippine Politics, Comparative Politics. Celia Torres Villanueva, Friendly Pharmacy, Contract and Intellectual Property Law, and DNA Vaccines. Kindly click. Okay. So join me in welcoming them with open arms and heart as they embark on this incredible journey with us. So I'd like to request all the members who are already here, okay, to do the oath taking, and for those participating via Zoom, please activate your camera and microphones for the oath taking. Additionally, we have the President of PASE, Dr. Gladys Completo, who will join us to welcome the new members.
Okay, so welcome to PAASE. Please raise your right hand and follow. I state your name.
I, Jericho Bacani,
Pledge to uphold the goals,
pledge of the goals
objectives of the Philippine American Academy of Science and Engineering
and objectives of the Academy of Science and Engineering
as a full or associate member.
as a full member.
I pledge to work to the best of my abilities
I pledge to work toward
and in a collaborative effort with the PAASE Executive Board and members
and in a collaborative effort with the PASE Executive Board and members
in the Philippines and around the world
in the Philippines and around the world
to promote the advancement of science, engineering, and technology
to promote the advancement of science, engineering, and technology
among scientists and engineers of Philippine descent,
among scientists and engineers outside of
to
Philippines,
support the advancement of research and development
to support the advancement of research and development
through scholarly and scientific endeavors,
through scholarly and scientific endeavors,
to recognize and honor the achievements of scientists and engineers of Philippine descent,
to recognize and honor the achievements of scientists and engineers of Philippine descent,
and most importantly, to work to increase the development of science and technology in the Philippines.
and most importantly, to work to increase the development of science and technology in the Philippines,
And the training of scientists who will shape the future of science and technology in the Philippines.
and the training of scientists who will shape the future of science and technology in the Philippines.
So help me God.
So help me God.
Congratulations. Welcome to PAASE.
So again, let's give a warm round of applause to welcome the new members of PASE. Pakita ulit ng Zoom for picture taking. Okay, for photo op.
Congratulations to the new members of the Philippine American Academy of Science and Engineering. We shall now proceed to the much anticipated awarding ceremony. Excited ba kayo? Si Sir Juice lang ang excited. For the awarding of the plaques, we would like to invite on stage once again the 2024 PAASE President, Dr. Gladys Cherise Completo. We shall first recognize our donors and sponsors. But before that, allow me to read the citation. The certificate of appreciation is awarded to for their invaluable contribution as sponsor during the 2024 annual PAASE meeting and symposium with the theme Filipino Scientists Across Borders Towards Developing Regional S&T Innovation Ecosystems, and a sub-theme Technological Innovations Towards Health, Food and Nutrition Security, held on July 15 to 17, 2024 at the University of the Philippines, Los Baños. Starting off with our sponsor, Color Application Specialists. Our silver sponsors, Levins International Corporation. Congratulations. Thank you. Diamond Enterprise. Southeast Asian Regional Center for Graduate Study and Research in Agriculture, or CIRCA. Optima Equipment Corporation. Our gold sponsors, Bioassets. Pascual Pharma Corporation. Rainfill Incorporated. De La Salle University, Manila. Now our platinum sponsors, Everlife Lifeline Diagnostics. Macare Medicals Incorporated. Office of Speaker Romualdez. Bihis Maala Basics. Department of Science and Technology. Joining them are Dr. Serafika and Dr. Lea Buendia. We also would like to invite on stage Dr. Julius Anyo. Thank you. Thank you so much, Department of Science and Technology. And finally, Department of Agriculture, Livestock Biotechnology Center. Thank you very much to our sponsors. And now, to award our finalists for the rapid fire presentation, may I call on stage our lead judge, Dr. Leah Tolosa Croucher, and our two judges, Dr. Carlito Lebrilla and Dr. Casiana Vera Cruz.
Good afternoon, everyone. We shall now recognize our rapid fire presentation finalists. Let me first read the citation. This certificate of appreciation is awarded to for being a rapid fire finalist during the 2024 annual PASE meeting and symposium with the theme Filipino Scientists Across Borders Towards Developing Regional SNT Innovation Ecosystem, and sub-theme Technological Innovations Towards Health, Food, and Nutrition Security, held on 15 to 17 July 2024 at the University of the Philippines, Los Baños. Our finalists will be receiving a certificate and a cash prize of 1,000 pesos. So the finalists are number 1, Paula Camille Ingala. Number 2, Flor Marie Emmanuel Pilapil Amante. Number 3, Lillian Isabel Trasena. Okay. Audrey May Aureliasa. Janina Guarte. Please come to the stage. Ralph Bernoulli Ramos. Jaira Nabel Bamba. And Honesto Ovid Tubalinal. Congratulations to our finalists. Okay, I think now we're complete. And now, for the most important part of the rapid fire contest, this certificate, let me just read the citation. This certificate of appreciation is awarded to for being a rapid fire winner during the 2024 annual PASE meeting and symposium with the theme Filipino Scientists Across Borders towards developing regional S&T innovation ecosystems and sub-theme technological innovations towards health, food, and nutrition security, held on 15 to 17 of July 2024 at the University of the Philippines, Los Baños. Our third prize winner will be receiving a cash prize of 2,000 pesos. Our second prize winner will be awarded 3,000 pesos, and our winner for first place will receive a total of 5,000 pesos. Congratulations. Okay. So third prize goes to poster number 36, Janina Guarte. Congratulations. Photo op, okay. Congratulations again, Janina. Second prize is poster number 11, Paula Camille Ingala. Congratulations, Paula. And finally, our first prize winner is poster number 51, Ralph Bernoulli Ramos.
Once again, our sincerest congratulations to the winners of the rapid fire presentations. We also extend our gratitude to our presenters, judges, and donors for their invaluable support towards the success of our convention. Now, to formally close this year's conference, we would like to call the 2024 PAASE Vice President, Dr. Maria Margaret Peña, for the closing remarks. A round of applause for Dr. Peña.
Okay, so we have come to the end of 2 wonderful, exciting days. And so before I say anything, I would like to invite you to join me in a loud applause of appreciation for the UPLB team led by our president, Gladys Cherise Completo. Woo! What a great meeting. What a great presentation. We were tired traveling from one place, from leg 1 to leg 2, but we were all energized by the wonderful talks, the presentations, by the presence of distinguished guests and members of NAS, distinguished members of PAASE, all those who traveled from afar, and of course, to every one of you, because without your presence, this meeting would not be a success. In addition, we would like to thank all of those technicians who are here, making this a very wonderful event. Meron pang mga teleprompter. Wala lang akong teleprompter. But everything went smoothly. To all of those who guided us from one location to another, everyone who took us on the shuttles from our hotel to here, from here to the parallel sessions, we would have been lost or we wouldn't make it on time without all of your very efficient transporting us from one place to another. To all the servers who made sure that we were fed, thank you so much. Sarap ng pagkain. And I know I'm forgetting, but don't worry, someone will come after me. So hindi pa talaga ito ang close. But anyway, in addition to thanking all of you for welcoming us and for this very wonderful meeting that I think will be probably remembered in PAASE lore for a long, long time because of how successful it is. My second job is to announce APAMS 2025. We're still in the middle of 2024, but let's look forward 1 year from now. So here's my slides, please. Okay, APAMS 2025. As you know, I'm announcing it because it will be in our neck of the woods, Columbia, South Carolina. So next slide. Where is South Carolina? This is the USC map. And there we are with the red arrow and the black circle. Those are the colors of the University of South Carolina, okay? So you have to travel to the East Coast, Southeast United States. Next slide, please. Okay, and that is the map of South Carolina. I specifically picked these colors because we are also known as the famously hot Columbia, South Carolina. So if you think it's hot here, it's just as hot where we are, okay? But I think we promise we'll get you air conditioning, okay? And so the circle, the bullseye, is the capital city of South Carolina, which is Columbia. We are in the center of the state, which makes it easy for us to travel to all 4 locations. Okay, next slide, please. And we are the capital of the state of South Carolina. That is our state capital. That's the back of our state capital. And if you go down there and look, that's the university. So right close to the university. And so next slide, please. The University of South Carolina is the flagship university of South Carolina. These are the gates to our campus, and it brings you into a very historic part of not just South Carolina, but the United States. So next slide, please. This is another view of the gates to the campus. These oaks are almost 100-year-old oak trees that line our campus. Next slide. Next. Okay, if you walk in, this is our historic horseshoe. This is the heart of our campus, and it has history because in the Civil War, this was used as the barracks of the soldiers, military prison, as well as hospitals for the wounded soldiers. So nowadays, there's no wounded people there, just students that can do a lot of things in the center of campus. So these are the trees. At the end of this, it's called the horseshoe because it's shaped like a horseshoe, a letter U. At the end of this, you can have 100-year-old oaks where there are hammocks that students can actually sit around. Next slide, please. There are places where you can sit down to contemplate on life. And there's a walkway around. If you want to take your 10,000 steps, you can just walk 5 times around the circle. Next slide, please. That's the Maxi statue. This is taken in the fall. Next slide. And most of the times next to this, you will find some faculty actually take the students and have classes on these grounds. But also on a warm summer day, you can find students sunbathing in this. It's also the scene for a lot of our sports activities. When ESPN comes for Sports Week, we have it here because it's the face of our university. Next slide, please. This is the house of our president. Our president lives on the horseshoe. So it's not uncommon for students to come knocking on his door. Mr. President, meron ba kayong sugar dyan? Kinukulang kami. So so he lives on campus. We have a lot of activities with the president. Next slide, please. As you go away from there, this is our library. It's called the Thomas Cooper Library. It looks like it's a small library, but it goes down 7 floors. It's on a hill. So you come in and then you go down. Next slide, please. If you move forward to the library behind the fountains, that's the smokestack. And from there, every day at noon without fail, the cock crows. Tuk, tuk. Here in the morning, you do that. In our university, it's at noon. Why? Next slide, please. Because our mascot is Kaki. So this is Kaki. He has won awards for being a mascot. And we are big on football. That's Williams-Brice Stadium on top. This is what it looks like when it's filled with rabid football fans. I can't say that we are championship quality in football, but even when we're losing the season, that stadium is filled to capacity with 90,000 people. Next slide, please. But we are good in baseball. We have been champions, national champions twice. Next slide, please. We're also good in women's basketball. We are the current national champion for women's basketball. We have an outstanding coach that has led the Olympic team of the United States. And we have statues of our basketball players around this arena. Next slide, please. Down across from our Coliseum is our Darla Moore School of Business. We may have some of our meetings in this. This is known for its architectural style. And also, there are lots of meeting rooms even on the rooftop. And we are known for our #1 ranking in international business. Next slide, please. And I'm showing you this because across from the Darla Moore School of Business, we refurbished our law school to become the Science and Technology Building. And this is where we're hoping to have our meetings because we are scientists and engineers. And this room, this building has our labs, and at the top floor is our AI Institute. So if you move to the next slide, this is what some of those inside of the building looks like. Next slide, please. The labs are in this building. Next slide, please. Next slide. Okay, that's the entrance to the building. You won't see the elevator. They encourage you to take the steps, but it's a very nice walk up all the way to the 3rd floor. So next slide, my final slide. This is when we're planning to do it. 26 to 28 is kind of enclosed in parentheses because that's, just a tentative date on when we would do it. But we would love to see you all come and welcome and experience the Southern hospitality, you all. We always say you all. Okay, so this is the next APAMS. As we close this leg of our 2024 APAMS, think ahead so you can apply for your visas if you need one. You can write your letters of invitation if you need one, and so on and so forth. And we look forward to doing that. Okay, so again, thank you everyone for being here. We had a lot of fun, those of us who came from abroad. And also, I truly enjoyed meeting a lot of you because I've seen pretty much a lot of you on Zoom. And finally, I get to see the real person. And then most of you also said, oh, now we get to see March. So it's why, likewise. So this is the joy of face-to-face meetings. We actually get to interact and see each other and talk to each other in person and build memories that will never fade as part of the Paase history. And I'm really just honored and proud to be with all of you and hope to serve you when my time comes. So this is not the close because I'm gonna call our convener and president, who's busy right now, Gladys Completo, to give the final, really closing remarks.
Thank you. Oh no, I won't be giving a closing remarks. I just so everybody keeps telling me congratulations, Gladys. It's really good. And actually I won't be able to do this without the UPLB team. So that's why I would like to acknowledge the organizing team from UPLB. Palakpakan po natin sila lahat. And I would like to invite them to come here, please. Dr. Cheryl Ariola, Dr. Belly Abrera, Amiel Valderrama, the chair and his team, Melvin Castrosanto, logistic.com and his team, and everybody else, please join me. It takes a village to raise a child. It takes a university to host this APAMS 2024. So please, come over here, join us. Palakpakan naman po natin sila. They really did all the hard work. Actually, siguro 50% of the Institute of Chemistry is here. These are all junior faculty members of the Institute of Chemistry. Okay. And most of them were my students. And I gave them all 1.0. No, just kidding. Hindi. So, dyan, sila po yung nangungurot sa inyo. Well, yes, please. Yes, of course. Okay. And the head of that is Dr. Cheryl Ariola, Associate Member of PAASE, and Dr. Belly Abrera, who is also an Associate Member of PAASE. Thank you very much. O, lapit na. Can we have a picture? And they want a picture with you guys. Yun yung kanilang, so iisa-isahin ko po kayo na magpa-picture sila. Okay. This is this is the UPLB team. Aside from that, nandito ba sina Dr. Edith Jose and then Basil Parlier? There are other, and Dr. Remil Galay. Wala na po, umuwi na sila, pero ito po talaga lahat nagtrabaho. Thank you. Melvin, yes, the logistics chair. Every day po, he's here 5 a.m. Okay, so can I join them? Okay. Okay na.
Thank you very much, Dr. Peña and Dr. Completo, for your messages. Please stay for a photo opportunity later, everyone. But before we end, please direct your attention to the screen for the video highlights of the first and second day of our conference.
The fourth annual PAASE meeting and symposium. The overarching theme for this year's conference is Filipino scientists across borders towards developing regional science and technology innovation ecosystems. Now, one key aspect of developing regional science and technology innovation ecosystems is collaboration. So we Filipino scientists have a rich tradition of working collaboratively, what we call in Filipino as balikatan, which means shoulder to shoulder, both within the Philippines and internationally. This spirit of cooperation is essential in addressing the complex challenges we face today, from health crisis to climate change. By sharing knowledge and resources, we can develop innovative solutions that benefit not just one nation, but the entire region and beyond. So I encourage all of you to actively participate, engage in discussions, and embrace the spirit of innovation that this conference embodies. Together, we can unlock the full potential of technological advancements to create a world where health, food, and nutrition security are within reach for all. Once again, welcome to APAMS 2024.
As we open today's symposium, we are reminded of the power of collective effort and the significant impact we can make when we pool our knowledge for greater public good. And here at UPLB, we strongly believe in the transformative power of trans, cross-disciplinary collaboration and partnership, and have consistently advocated for it. So today, we are witnessing an agora here at Baker Hall, led by PAASE. And in the same vein, this symposium is a very testament to that belief, bringing together diverse group of thought leaders, researchers, and innovators from around the globe to explore and to enhance our understanding of how technology can secure a healthier and more sustainable future for all. The insights that we all gain and the partnerships that we all forge during this symposium will shape our collective journey toward a future where technological innovations stands at the forefront of health, food, and nutrition security.
Science and technology in the Philippines face significant challenges impacting the country's global innovation performance. the Department of Science and Technology will continue to focus on pushing science, technology, and innovation-driven economic development through strategic investments. Our strong performance in innovation outputs relative to inputs highlights our capability to convert research and development investments into transformative innovations.
And there you have it, days 1 and 2 of our conference. Of course, I would like to remind everyone to please sign the registration form at our booth near the entrance and to please accomplish our evaluation form for days 1 and 2 using our QR codes. Again, you may scan the QR codes for our evaluation forms at the back of the program brochure. You may also find it here on our screen. You will receive your e-certificate in your email in 2 to 3 days. All right. So thank you everyone for joining the 44th Annual PAASE Meeting and Symposium or APAMS here at UP Los Baños. We look forward to seeing you next year at the 45th Annual PAASE Meeting and Symposium at the University of South Carolina. On behalf of my co-host, O'Neill Flores, I am Vanessa San Juan, and I have been your host for this afternoon, for this day. Have a great night, everyone. Please stay for our photo op. Let's start with the Board of Directors of PAASE. We'd like to invite the Board of Directors on stage for the photo op.
While the board of directors are going to the stage, I have to introduce two very important people po who's been helping me virtually. So I would like to call on Feb and Andra. Please come over. Feb and Andra are assistants, virtual assistants, but they came here from
Please stand by our plenary speakers. Please stand by our plenary speakers for the photo op.